My name is Katero, and I'm with Johannes here. We will be sharing the work that we have done at Implex with regard to declarations of our MRM report after we've incorporated our risk. And that was a process of evolution. Okay. Since, well, this is a mineral resource and reserve session, I thought I should start with mineral. Okay, so I'm trying to, okay, I was trying to move my screen, it wasn't moving. I thought let me first explain the context in terms of our mineral economics first to relate with the topic of today. I want us to realize that, I mean, this industry contributes roughly 494 billion actually in 2022. I use this information from Mineral Council, and we can see that in 2021, it was 475. This was a growth of 4%. This is despite that the pandemic that we had in 2020 and 2021 of COVID-19, we still improved by 4%. And let's realize that it's still a major player in terms of employment, where 475,000 people are still employed in 2022 with regard to this industry. You can see other items that I'm not going to go in detail with because I believe you will get this presentation. In terms of the corporate tax, you can see that we are contributing 74 billion. And when I say we, I'm not referring to Implex, I'm referring to the industry as a whole. Just to give a context of how important is mineral economics in this country. On our next slide, the question is that why do we really need risk management in MRM actually? First of all, we need to realize that all these minerals, they are owned by corporate organizations. Implex is a corporate organization, then it is bound by a code practice by King 4 to declare all their risk to the stakeholders. And if they have to raise their fund, they need to go through the JSE, which also expect them to declare their assets and mineral reserves. Luckily, there is some code which is also supported with JSE to support our competent person. And there is ISO 31000 that says, explains how risk should be managed in totality from enterprise and even to technical level. And thanks to GSSA, which ensures that we still have our competent people who will still remain professional and uphold the conduct. And hence, I had an image of the board team there taking decision to say, I mean, we need this to enhance the decision-making board members. This slide shows, talks about collaboration. In order for us to achieve that, to ensure that we have a MRM risk assessment that could enhance decision-making for our board members, we had to do a lot of collaboration, and it was led by MRM team, where Johannes came to our department, say, risk team, can you come together with us, together with ESG, and let's build something that will represent MRM. Because previously, as I will present in the next slide, you will see that most risks were generic and they were of the business or commercial side. The group risk initially were more commercial. They included cost. They talked about electricity. Yes, if you look into modifying factors, one can say indeed they are modifying factors, but they didn't have a flair of mineral resource and mineral reserve. You can find a link, but it is a little bit far-fetched. Then prior 2021, we decided that we will work on something that will give more of MRM flair, and it will explain the technicalities of MRM. And that process took us 2 years. And when I say we, I'm referring to ESG team, MRM team, and risk functions. But when we were doing that, we realized there was a challenge actually in painting the picture of the risk in the operations and on how we aggregate all those risks to group level. Because how do you present the risk profile that does not distort material risk at the operation when you present them at the group level? Then as such, we realized that there was a need to establish a process and a standardized process that will add value to all operation and the group and still honor the compliance of the summary code in terms of reporting risk. On this slide, the one I think I would not even claim to be an expert on this in terms of summary code. I believe everyone who's here understands very well Section 11 of summary code that was published in 2016, where it emphasized that the competent person actually really need to take care of the risks that are disclosed and even shared with JSE or other stakeholders, or even on geological model. Ensure that all the people who use that information understand those risks and can take improved decisions and informed decisions from the competent person. I wouldn't go in detail on that, but now that keeps on referring to risk. The question is that what is risk in this case? Because risk can be generic. People view it from business point of view. Some view it from safety element. But I want to take you back to ISO 31000, which define risk as effect of uncertainty on the objective. And in this case, our objective is to ensure that our board of directors, our stakeholders and shareholders can take effective decisions that allow sustainability to our business. In this case, it means we really need to focus on effect of incomplete knowledge of our geological body or modelings in terms of a competent person. And for that, I will hand over to Johannes, who will now explain in detail, as he is a competent person, and I believe that through this integration, he now understood how risk can be integrated into our minerals resource.
Thank you very much, Katlefu, for setting the scene here. Greatly appreciated. As Katlefu mentioned, this was really a collaboration over 2 years between us in the MRM department and the risk department, and also to some extent the ESG department. So what we want to share with you here today is the learnings over the last 2 cycles of us, embarking on this process, where we want to remind our competent persons of their responsibility in terms of understanding the ore body, putting information or gathering information to better understand our grade, quality, and quantity, and also the reasonable prospects for eventual economic extraction. So for today, it's more to explain to you our process in terms of the mineral resources, the different categories, measured, indicated, and inferred. And if you understand, the risk in that space, how that then, translates to the mineral reserves as you are, modifying your mineral resource. And also, what we have learned throughout the process is, if there are risks in that space that's unidentified or unknown, then there's also a risk as that forms the foundation of us as a mining company. I want to start, first of all, that with the people. So for the competent person, it's very important to first ask the question, do we have risk in this space? Without people, the rest of the job cannot happen. The health and the safety, the skills and the experience of our people. So once, we as competent persons can tick that box, then I feel, we can then move forward to the next step. The next item there is mineral rights and legal tenure. We all know that it still happens that companies are losing their prospecting rights or have the risk of losing it. So again, here it's the collaboration between the MRM department and your legal department to ensure and know if there are any risks in that space, and if the company is still in good standing in terms of prospecting and mining rights. So once, we know there are no risks there, we can then move on to the next step. As you all know, that currently we are in a time where metal prices in the PGM industry are depressed, budgets are cut. So in this step, we as competent persons now need to see, what are the priorities. It could happen that in this case, you are neglecting to drill, for example, in your inferred category, to do that systematic upgrade of your mineral resource categories. So you could now end up deciding that, you've got a your budget has been cut, you can only drill, for example, in the indicated category, where that systematic upgrade of your mineral resource from indicated to measured can happen. So if this continue over time and you only have budgets to spend money in the indicated category, that systematic upgrade, and as you deplete your ore body, can become a risk over time. So it's important that the whole team, the MRM team, and especially the competent person that are responsible for exploration and mineral resources, critically look at this and identify risk in the specific area. So once that budget is approved, the next step is now the execution. And this is where the exploration geologist is really in charge. We have recently visited one of our core yards, and I must say that, if you enter that workspace, you really get a warm feeling that housekeeping is well managed. The whole chain of custody is well managed in terms of drilling, logging, and sampling, and all the way through to the validation of the data and QA/QC. So that provides a warm feeling. One can immediately, see if there are, for example, a risk in that workspace. But it's also the duty of the exploration manager to ensure that if there are risks in this workspace, that it's well understood and mitigated. Once the exploration geologist completed this work, the next step is to hand over this work to the geologist that will be responsible for the resource evaluation and for updating structural models. So in this next space, it's now to start preparing models for handover to our mining engineers. Here, obviously, we'll do the interpretation, the modeling, the estimates, classification, and reporting, and also ask the question about RPEEE. And again, in this case, we need to also understand, do we have risks here or not, and make sure that if there are, that we have got a process to mitigate those. Then here, I also want to just mention to you ESG. We all know that it's a topic that is widely discussed at the moment. It's important that we, as mineral resource practitioners, geologists, understand, where's our responsibility, where does it start, and where does it stop. We also are collaborating quite well with our ESG department to make sure, in terms of our reporting, that we cross-reference, to make sure that we cover all the aspects that are related to ESG. In terms of audits, it's also very important that we as a company can demonstrate our third-party oversight in terms of our geology and our mineral resources, but also internal oversight from the corporate team to make sure that, we've got a process in place to, if there are audit findings, how do we do work to address those audit findings and to have a close-up process, and to make sure that it also adds value to our business. So once this whole process is now concluded, we are at the point where we now going to hand over these models to our colleagues, our mining engineers. So what we want to share with you here today is that we have embarked on a process so that we can identify risks in this space. And to make sure that, if there are risks here, that we are well aware of it and have got processes in place to mitigate those risks. The next slide is focusing a bit on the handovers and the risks that are associated with that. As I explained previously, the exploration geologist, the competent person in that space, is responsible for executing that budget in terms of the drilling, logging, and sampling, the data validation, QA/QC, and the sign-off of the database. After that work is completed, there's that handover, that stage gate that takes place to the resource evaluation geologist and the geologist that will be updating the structure model. So, again, we need to understand, are there risks there? What are we doing about it? Making sure that we've got a good handle on it, because now we are at the point where we are handing over these models. And I think it's important that we also encourage our geologists to stay involved in this whole process, because our work is now going to be used to modify it and to get to a point where we can estimate our mineral reserves. But it's very important that we have, for example, version control. I've seen in many cases that a project is done on a geological model that's, for example, 2 or 3 years old, and never considered the latest drilling information. A lot of that design work is based on older version, and a lot of rework need to happen. So I always want to encourage our competent persons on site to remain involved, to make sure that the models that you have put together are used, the correct ones are used, the most updated ones are used. Also make sure that the mining engineers know, where did you add information, do reconciliations, so that the new information is informing the latest and greatest mine plans and life of mine plans. And if there are risks in this part of the process, it could also have quite a big impact on the NPV and the evaluation of the project or the existing mine. What we have done also is we have put together a severity scale in collaboration with Geological and the risk department, because before we only had a severity scale for profitability, reputation, and productivity. It didn't exist specifically for mineral resources. So we went and we put together the severity scale to consider tenure, data support, QA/QC, geology, grade, classification, RPEEE, and the reporting of our mineral resources, and also ESG. And we have established this to rate our severity. We've put together the 3 different ratings that are there in green, the 2 in amber, and the 2 in red. So once we are in a position where we can rate our severity, then we can go across to where we do the risk rating. We've got a combination of rating the likelihood and the severity, and ultimately, ending up understanding our risk in the different areas. So on operational level, we then established a risk register that are used on site by the different competent persons. Here I'm just sharing an example of what is used on one of our sites for tenure and data support and QA/QC, where the risk identification takes place, where we ask all these questions about the source of the potential harm, the unwanted event, the potential situation or condition where the hazard is present, the risk rating, the cause, and then we look at the controls. What do we do about that risk, the overall control, the assessment of the controls, and if further mitigation needs to happen, then we report all of that. So all these different items are then registered on this template, and at the end of the day, this is then also captured in our Cura system by our risk department. So what we have done here is this process was guided by the SEMRAC code, looking at what is our responsibility as competent persons, making sure that all our competent persons are aligned. We've done this for the group, for our managed operations, and also our non-managed operations, our JV partners. So this structured approach and standard approach allowed us to be aligned and to eventually get to a point where we completed all our risk assessments for our geology and mineral resources. And ultimately, we did that also for our mineral reserves to get to a point where we can now look at the risks for the group, and then how do we report these per operation and for the group in our public reporting. So here I'm just showing on the left-hand side the top 5 risks that we have declared now in 2023 for the mineral resources. I also show on the right-hand side the risks that we have declared for our mineral reserves, the top 5 risks. So what we also have seen throughout this process is that these different items are relative measurements. If I can just take an example, skills retention, it's listed secondly on mineral resources, but it's listed as a 5th risk on mineral reserves. Not saying, you know, that it's a higher risk specifically for mineral resources, but relative to all the other items, that's where we see the risk at the moment. We also have learned throughout this process that, yeah, there is some subjectivity that's related to this risk. And we also, you know, use our expert judgment throughout this process. When we looked at the risk aggregation on a group level, we also saw that, you know, you cannot, you know, apply a mathematical approach, but it's more of a art and science. And risk is dynamic in nature, and it evolves with time and the discovery of new information. I want to, you know, get to the end of our presentation. And first of all, I want to thank my colleague Katlego. I think what we have managed to do with this process is to integrate the MRM department and enterprise risk. We really had the opportunity to now meet our governance requirements for our stakeholders. We are now ensuring that our competent persons on site and here at the corporate office comply to the SAMRAP code. We have put together a structured and a standard approach that stimulates the competent person to reflect and better understand the risks in geology and mineral resources that enhance our confidence and our management of risk mitigation. And we also believe that our reporting is now more transparent, and we have enhanced it for our stakeholders. Thank you very much. We are open now for any questions if there are.
Yeah, thanks, Nicole. Just a question, you've got market risk as your highest risk factor for reserves. Would you consider downgrading your measured resources to probable reserves because of that risk factor? In other words, because of price and market?
I'll take that one, Matt. At the moment, it was not a consideration. We do, however, have areas where our measured category have been only converted to a probable reserve, but it was not for market conditions specifically. So that's not a current consideration at the moment. But yeah, time will tell. But that's not something that we consider at the moment.
Okay. Thanks very much.
Sifiso?
Apologies. Can you hear me now?
Yes, we can.
Thanks, Johannes and Katlego. Just a question on slide 17 on the risk assessment that's done. My understanding that it's done by the CPs on site. Is there any independent overview on that just to ensure that there's consistency in application, or how do you guys approach that? Thanks.
Okay, thanks for that. Yes, I mean, coming from a risk function, our role actually there is to ensure that we are independent, and we ensure that they adhere to the standard that we would have set, because we understand there is a risk of subjectivity. On operation, once they've done it, we will cross-check with other operations. We have a committee call where we find that all operation CPs, they meet and they will review the risk register for the holistic operations and even the group. In that case, then it can remove subjectivity, allowing me as a risk facilitator to now interrogate the competent person with regard to their ratings. And if you check that template, before I can accept some of their ratings, they really have to prove and explain why they say their controls are rigor. Hence, there you will need a risk practitioner to facilitate the process, and you need a CP to guide in terms of technicalities. I don't know if it helps.
Yeah, yes, it does, Katlego. Thank you very much. Asked and answered. Thank you.
Maybe if I may, Johannes, I saw on your on that risk assessment, you talk about ESG risks that are some of the risks that you guys have a look at. I'd just be curious, obviously, with all the discussion around ESG in the industry at the moment and incorporating that into mineral reporting. I mean, what are some of the topics that you would consider important to look at that would affect your resources and ultimately your financials at the end of the day?
Thank you, Nicole. Yeah, I think, in terms of, if I can use an example, in terms of exploration, obviously it's, there about our environmental processes that we have in place to make sure that, once we are leaving a drill site, for example, that, we are making sure that we leave it as we found it. So, and I mean, small things in our core yards, for example, is to make sure that we've got, all the different measures in place to make sure that we tick all the environmental boxes. And then also in terms of governance in our communities, the way we, handle, the relationships in our communities. We know these days that your collaboration between your exploration team and your stakeholder team is very important. So I think, the way that we do that consultation up front before we go and drill, I think that's one of the areas that we have improved on significantly. There are still areas at some of our operations where we need to get better. But yeah, those are small things that we try and do. But we also are very careful to make sure that we know, what is our responsibility, where does it start and where does it stop. So we make sure that we collaborate with our ESG department so that we are well aware of what is our responsibility and then what is their responsibility. So I think that's also very important to make sure that you don't take things on your shoulders that are not actually your responsibility as the geologist. I hope it helps, Nicole.
No, 100%. Thank you. That's a very good point that you made at the end there. Thank you very much. There's a question in the chat. I'm going to read it for you. Hi, Johannes. What did you mean with risk 3 data support? And did you consider the inclusion of other departments or functions that can in advance highlight possible risk or considerations throughout the resource process? Example, geotech, mining, metallurgy, and marketing. That's from Kwiti.
Okay, thank you very much, Kwiti. Yeah, in terms of data support, obviously, what we mean there is that if you do not have adequate amount of data to support your conversion from the mineral resource to a mineral reserve, that is a risk. If I can give an example, I've seen that life of mine plans could sometimes, enter into inferred categories to maintain a certain life of mine profile. And it could be that there's a community issue in that specific area, and it's hard to go and, drill there. So there is a risk in that specific area, but it's part of a life of mine profile to maintain a certain production output. So in that case, it's only when that drilling can be done to upgrade that specific inferred category to an indicated category to allow the competent person now to convert that to a probable mineral reserve until that drilling has been done, until that data can support a indicated category, there will be a remaining risk in that area. So in terms of our process, we have involved our ventilation department, our rock engineering department, our metallurgists in the event of doing a risk assessment in our mineral reserves. I must say we did not really, involve our marketing department in this case. But yes, all our technical departments have been involved in these risk assessments, specifically on the mineral reserve side. So I think that was also, to me, a lot of, I think a lot of value was added there, because we have provided the process where we allowed those rock engineers and ventilation engineers to really apply their mind and to start thinking about the different risks in their areas. And those we could also capture in these registers and also in our formal Cura system for annual updates.
So just a very brief introduction to Dennis. Dennis started his PGM mining career at Northern Zondereinde mine in '95, and we've gone full circle and he's back there now. And after 10 years in Botswana, Dennis returned to PGM mining at Lonmin Platinum, and he's currently Northam's Group Mineral Resource Manager, where he's been in the role for the past 5 years. So with that, thank you very much, Dennis. Looking forward to hearing your presentation.
Yeah, good morning, and thank you, Nicole, for the introduction. I've been privileged to have started my PGM mining career at the Zondereinde mine, and even more so, I'm privileged now to be able to come back to the mine with its new developments 25 years later on. The contributors to this presentation are Damien Smith, who is our lead competent person for Northam. We have Charles van Jaarsveld, who's the MTS manager at the mine, and our chief geologist, Mpumelelo Tobeti. Our talk today is about sharing really some of the insights into the Merensky Reef facies at the Zondereinde mine, and a little bit more about the deep level mining at Zondereinde, which has always been a benchmark for deep level platinum mining. And I'll take you through an introduction to the mine and its resource base. We'll have a look at the Merensky Reef and its associated facies, some aspects of the estimation process, and we'll share some operational controls and production history of the Merensky. Northam has 3 wholly owned mining operations in the Bushveld complex and a joint venture. We have the Booysendal mine on the eastern limb. We have the Eland mine near Brits in the area here, and then the Zondereinde mine up between Northam Town and Tabazimbi. The company is on a growth trajectory to produce 1 million ounces of 4E per annum. And we're currently at the point where in the last financial year, we produced 832,000 ounces. In total, the mineral resource for Northam is over 200 million ounces of 4E metal, and we have nearly 30 million ounces in reserve. Now, the important thing around the Merensky Reef is that we well know that the western limb is actually quite different to the eastern limb in its characteristics. The eastern limb being more of the wide reef with lower grade than what we see on the western limb. And in the interesting numbers that I've tried to put together is the current resource limb for the Merensky on the western limb. We have about 210 million ounces. These were taken from 2022, and there's about nearly 37 million ounces in reserve, of which Zondereinde accounts for 19% of the resource and 16% of the reserve. Now, the interesting comparison is that on the eastern limb, there's a similar amount of metal in resource of 210 million ounces, but very, very little in reserve. And that testifies to the difference in the, in the nature of the Merensky Reef on the two limbs. In the right-hand side, you can see where the Zondereinde mine sits. It's down dip of the Amandelbult, which have got the two mining districts, the Tumela and the Dishaba. And in the picture on the right-hand side, you'll see the new shaft complex, the headgear that's been erected. And in the background, you can see the old one shaft and two shaft. In summary, Zondereinde has a large mineral resource base and sufficient quality to support long-term operational growth. Right, the Zondereinde mine started sinking its 1 and 2 shafts in 1986 by Goldfields of South Africa, and we had early production in the early 1990s, and thus the mine's been operationally active for over 30 years. The 3-shaft complex, which is underway, has recently completed its first raise bore hole. It was reamed from a depth of 1,382 meters, which is a world record for a raise bore shaft. It's got a diameter of 4.8 meters. The 3A shaft, which is the ventilation shaft, the piloting has been completed there and raise boring is in process. And piloting of the 3rd shaft is underway. So a lot of activity happening in the western extension area. And the mine's really divided up into 3 major mining districts. The Zondereinde section, which is largely been mined out on the upper levels for the Merensky Reef. And the effort on mining is into the western extension. And then we have the Middle Drift section out on the eastern side, on the northeastern side, which is still remains in a low confidence resource, and very little, or some minor work has been done on looking at scoping. At Zondereinde, the Merensky Reef occurs between a depth of 1150 below surface and extends to below 3,100 meter level. Northern has progressively extended its mining from about 2,000 meters to 2,400 meters over the past 10 years. And we anticipate mining at some stage in the future up to a depth of 3,000 meters. The Zondereinde mine is without any doubt a leader in setting the benchmark of deep level PGM mining in South Africa. We currently produce 2 million tons of run of mine ore for about 300,000 ounces of PGMs. Right, getting on to the geological side now. On the slide in front of you, there's the 2 facies, it's known as the Swartklip facies, with 2 subfacies types. The normal shown in blue over here, in the Zondereinde section, as well as in part of the Middle Drift section. There's also another facies, which I'm not going to talk too much about, is the Hartdoorn facies. It's a very small variation of the normal facies, and for now we'll just treat it as one. And then the rest of the area that you can see, this white area over here, that's in the western extension, and that's called the regional pothole facies. In the shallower areas, that's mostly been mined out. And we have a transition that I'll go into a bit more detail between the normal facies and the regional pothole facies, which is basically sterile type ground with little resource potential. We don't declare any resources. But looking at metal content, the regional pothole facies and the normal facies are roughly a 50-50 split. Right, onto the Merensky facies in a bit more detail now. The Merensky Reef is essentially a mineralized envelope that straddles the base of the Merensky chromatite. So what happens is, in the normal facies, is that we have a chromatite at the base and a peroxenitic package above, and this chromatite seam rests at relative positions to various stratigraphic layers or key markers. And in this case here, we sit at the top of the stratigraphic sequence. We have the normal reef. We have a little bit of mineralization that encroaches into the footwall anorthosite. And as one progressively cuts down into the regional pothole facies, we have a transition zone where the Marinsky chromatites not well developed. There's steep angles that makes mining impractical or sub-economic. And then the Marinsky reef then stabilizes at various stratigraphic horizons. So we have the next facies down, which is called the NP2 Marinsky reef. And that rests on a resistive anorthosite layer. So it's about a 1 centimeter thick anorthosite layer. And it stabilizes there. It has, I'll show you metal distribution peaks shortly. That accounts for a smaller portion of the mined area. And then it cuts down through onto the P2 chromatite, or just above the P2 chromatite. And that's known as the P2 Marinsky reef. And then where it cuts below the P2 chromatite, it's known as the footwall P2 chromatite. And there are occasions where it actually cuts down even deeper, but those are not mineable. Important to note that most of the regional pothole is approximately 40 meters above the UG2 and approximately 60 meters from the normal reef to the UG2. So essentially the Marinsky reef is a zone of mineralization that straddles the base of the Marinsky cyclic unit. Right. The normal reef, as you see in front of you over here, here's the top chromatite, which is associated with peak mineralization. It also has a higher platinum to palladium ratio, and you'll see that similar trend occurring also in the regional pothole facies. These can be very high grade, these peaks over here. The thickness changes as you get closer to the transition. We have a narrower cut of 1.2 meters, but for the greater part, the actual normal reef is mined at a 1.6 meter cut in a conventional sloping environment. So the cut basically goes from 10 centimeters in the hanging wall and 10 centimeters in the footwall and whatever is in between. In the regional pothole facies, we see the three types, the NP2. It has a single peak. You can see the chromatite layer developed over there. It's mined at a 1.1 meter cut with this troctolitic material in between and an anorthositic footwall over here that carries lesser mineralization. The star of the facies is obviously P2. It's got the higher grade, and you can see the well-developed P2 chromatite here, the hard-spagitic pigmentoidal texture over there, and quite a thick Marinsky chromatite unit over here. That's mined with 10 centimeters into the hanging wall and 110 centimeters below. And the significance of mining a fixed cut, I'll explain in the subsequent slide. Where this top chromatite over here cuts through the actual P2 chromatite that you see below here, you get the footwall P2, and there is more mineralization that rests in the hanging wall, and you've got this pigmentoidal hard-spagitic zone below here. Again, only a single peak of mineralization. Right, in summary, the four different mining cuts, and these are shown to have a fixed cut throughout. We believe that applying a fixed cut to a variable Marinsky facies has worked very well for Northern, for Zondereinde. We have avoided trying to go the route of any variable thickness cut. The complexity of trying to implement that is always very difficult, as I've seen from previous mining operations that I've worked on. The important aspect, on average, we have about 71% extraction. When we apply our geological losses, it's a total mining and geological loss combined. to give us the 29% loss or 71% extraction on average. We're finding as well that certain facies have better extraction than others, with the highest extraction found on the normal reef and the worst extraction found on the footwall P2. However, as we're progressively mining towards the southwest in the western extension zone, we've seen that the Merensky becomes more conformable, and thus the extraction improves. Right, so onto the data side of it. There are three types of data that are used to inform the mineral resource estimate, and these comprise channel sample sections. We have surface borehole, and more recently we've engaged on doing underground borehole sampling of our plus 90-degree holes. There's a large mining history of 6.5 by 2.6 kilometers. You can see from the statistics over here that there's in excess of 35,000 channel sections that are used. It's an incredibly close sample spacing that is being used. And because of the depth of the resource, there's obviously lesser surface boreholes. But in summary, you can see the proportions of the channel sample data, and well, it's combined channel and borehole together, mostly influenced by the channel. And the most dominant, obviously, is the yellow, which is the P2 facies, with progressively less NP2 as we go southwest, and obviously an increase in the footwall P2 in this district here. The normal reef has been mostly limited to mining in this area here, which is where the access has been on the shallower portions of close to the shaft block over here. So three different types of data that have been used, and channel being the most dominant type of data that's used to inform the resource estimate in the immediate mining workings, and then obviously the borehole data also used to inform the more distal areas. Right, so the other important one is when we start looking at the the proportions of the different facies types. We've applied a technique, indicated kriging, to assist with the providing an estimate ahead of mining. And the first thing that we did was to combine the P2 and the footwall P2 and look at the ratio of these two, and then separate out afterwards the P2 from the footwall P2. So just taking the P2 proportions or the probability of these, you can see that beyond the data, the actual, the reliability of indicated kriging actually does fall apart. And so the indicated kriging is only used to inform our measured resources immediately ahead of mining, and we have a fairly conservative measured resource definition. And then the global averages are then used to inform the facies proportions in the more distal and the indicated and inferred areas. Right, the grade estimation basically follows very much a standard approach that's used widely in the PGM industry. Our resource cuts are defined over the required mining width. We have fixed thicknesses applied to all the facies. On the right-hand side, you can see the grade distributions for the different facies types. And they all have some very, very similar grade distributions. They all tend to be close to normal with a slight skewness. Interesting to see that the coefficient of variations are quite similar, less so for the normal reef of 35 to 39%, the NP2 being much more variable, and the same with the football P2, and P2 having about 36%. Composites are done in data mine. The variography is quite interesting in that the model types that we see are largely nugget type models for the grade. There's very little structure that we observe. And so we still apply ordinary kriging to allow the kriging to decluster the data. Essentially, it's, yeah, we don't have those typical spherical variogram models. So there's a need for large amounts of data to get a reliable local estimate. One of the successes or one of the critical items required, in the control environment is to have information of the facies immediately ahead of mining. And underground prospect drilling is essential to delineate the facies immediately ahead of the on-reef development. In our last financial year, we drilled over 360 underground prospect boreholes with about 42 kilometers of core. The early ore body information from this drilling is a critical success factor in defining the mining layouts. Most important, obviously, is to understand where footwall P2 occurs, and you can see these red dots over here indicate footwall P2, and the reason why footwall P2 is because of the low extraction, so it's important to know where these occur. So the short-term prospect involves first drilling along the raise line to define the facies along the raise line, so it gives some information ahead of what to expect during the development, and then to subsequently follow up with expanding the drill pattern to include the peripheral areas. Yeah, then there's the further controls that are in place, which include the high frequency of underground visits. There's approximately a 200% coverage of all panels during a month. We also have our gullies put out at a tactical angle of 20 degrees relative to the center line, which ensures that any facies changes can be negotiated. There's also a focus on training and identification for mining personnel and the application of the correct mining cuts. So in the long of the story is, information ahead of mining has come by extensive underground drilling to ensure that planning is done correctly and that we're able to get the maximum out of each of these stopes. On the top right-hand side plot, you can see these little dots over here. These are where the plus 90-degree holes have been drilled. So we're increasing our database of more robust data. All of these plus 90-degree holes have got a 6E assay analysis, which also helps in delineating or defining the pearl splits. Right. With all the underground monitoring of the facies proportions, this has been done back well over 20 years ago. You can see the plot over here starting in the year 2000 and up to current over here. The red being the footwall P2, the yellow being P2, and the green NP2, and the blue is the normal reef. Normal reef is mined in lesser proportions because of its access in the deeper levels. And so there's a long history of production monitoring. And you can see over in recent years, there's been a trend to mining less normal reef. So the concentration of mining is more in the shallower levels. But also interesting to see here is that there's an increase in the proportion of football P2 facies where this facies has become more conformable. For the greater part of the earlier years, the football P2 was largely unconformable, difficult to mine, large proportions of dilution coming in, and we hope that this trend will continue to be like this. So a large amount of data to rest our future projections on. And yeah, so really just in summary then, you know, the Merensky Reef facies are well known in the South African PGM mining industry. To control and define the mineral resource cuts, we're doing something very similar at Zondereinde. And at Zondereinde, the Merensky Reef occurs as a mineralized envelope, which has higher grades around the chromatite layers. We have a fixed thickness resource cut for each sub-reef type that represents the mining cut. It's a pragmatic approach to using in the block model for grade estimation, also in monthly ore accounting and in marking off stope faces. And yeah, continued monitoring and accounting of Merensky Reef facies types and its grade variability and extraction history over 30 years has contributed towards Zondereinde mine success. And in summary, thank you very much for your time. I'd like to just share with you is 4 generations of chief geologists covering 30 years of mining are still associated with Northern Zondereinde mine. On the left is Charles, Damien, thereafter myself and Mpumelelo, and quite an honor to have 4 generations of chief geologists still associated with the mine. Thank you very much.
Thank you very much, Dennis. Nicole has had to step away, so you have to bear with me for the next little while. Matt, you have a question. Go ahead.
Yeah, thanks, Tanya. Dennis, excellent talk. Thanks. Really nice to see the progress of the mine. I remember when it started in 1986 to great fanfare in Goldfields at the time. Just a quick question. You mentioned about the conservative classification of measured resources based on your indicator approach. That's not a SAMREC requirement. Is that a corporate overlay or a northern sort of instruction to be conservative?
It's a northern requirement. You can see in when you look at different PGM resources, there's different degrees of understanding of geological continuity. And the challenge when you've got the regional pothole facies is to know what the proportions of the 3 different subtypes are. And if, for example, you had a district where, let's say, 60% would be football P2, then your extraction would deteriorate significantly. And you know, so it's very much about the confidence of the proportion of the facies types, and that's why we've kept it to basically be 200 meters ahead of our current development, where we have drilling and raise mapping to inform the measured resource. Beyond that, it's really about borehole data and some extrapolation.
Yeah, that makes sense, and you've got a lot of detailed underground sampling to back up the
correct. Yeah,
that's pretty good to see. Okay, thank you.
Thanks, Matt.
Anybody else have a question? Yes, Moses, please go ahead.
Yeah, thanks for that presentation there, Matt, and thanks, Nico, for letting me in. I just want to ask, I think it was slide 8, if we go back to in terms of grade control, you mentioned that when you mine there, you cut off also 10 centimeters in the footwall and also in the hanging wall. Do you then further separate that when you process, or you just process everything together? Do you actually then separate the food wall and the hanging wall from the layer reef itself.
Sorry, Moses, could you repeat? Do we process it separately, or or in the estimate?
Yes, that's what I'm asking.
So,
if you
okay.
further
So, sorry, I should have been a bit clearer on that. So each composite, you'll generate a grade model for it. And then after the grade model has been generated, we then apply a proportion of each facies type. And in the area immediately ahead of mining, we'll apply the indicated kriging to use that tool to estimate the proportions, and then beyond the measured resource, so into the indicated and inferred, we then apply a global average based on a zone further back from the current faces. So from the mined out area, we know what the global percentages are, as you've seen, on one of the later slides. And that gets applied to the areas beyond the measured, so in the indicated and the inferred. So each facies has its own grade model, and then we proportion out the facies based on different rules that we have.
Oh yeah, thanks. That helps. Thank you very much.
We have a question from Pateke in the chat. Are the underground prospect boreholes also used in long-term modeling and resource estimation?
Yes, they are. It's an initiative that we've started to get going about 2 years ago. So we have at this point a relatively small proportion of them relative to the channel samples, but that will increasingly allow us to get a better prill estimate going forward. So the earlier data only had a 4E prill estimate, and now with the underground boreholes, we'll have a 6E prill and have a better, bit more of a better estimate of the local variability of the individual elements. And so the boreholes are going to be a useful part of the estimate going forward, mainly for the prill estimates as well, and also to get some idea of a more reliable, wouldn't call it more reliable, but a different assay method relative to the channel samples. So the underground boreholes get done with a nickel sulfide collection and a mass spectrometer finish, whereas the channel samples are lead collection and with a gravimetric finish. So important to understand and reconcile the two different types of data.
Joined Earth Lab Technical Division in 2018 as a grade control geologist, and he's currently working as a resource geologist. But he also has experience in surface and underground mining, exploration, project management and planning, and general geological consultation. His software skills include geological modeling and mineral resource estimation, GIS, project management, and data analysis. As an analytical thinker, he thrives in problem solving and system optimization through data analytics. He is meticulous and methodical, being distinctly comprehensive in planning and management tasks. So with that background, Marius, we look forward to your presentation on tonnage estimation. Thanks very much.
Thanks, Tanya. Thanks, everyone. Also, I wasn't really sure what the makeup of our audience would be today, and or what the topics of all the other talks would be. And hopefully this talk is neither too technical for the more junior audience members or not too basic, for the listeners that are more experienced. I was aiming for something kind of in between, and to introduce a concept or two to people that are unfamiliar with the world of geological modeling and resource estimation. And from my time in the industry, I've seen, some of the items that I discussed today are are not necessarily general knowledge. And I'm also very excited to hear Jeremy Whitley's talk on density, because I only swiftly touch on the topic, but I think his talk will be very insightful because, like his talk is also named, I think density is often neglected and regarded as an afterthought. So, I'm excited to hear Jeremy's talk a bit later. Because there's a slight delay on my side. Okay, so before I even get to the table of contents of the talk, I think it's important that we just first establish the meaning of the word tonnage and why I chose that specific the name for my talk. But in retrospect, I could have also, you'll see why I could have also maybe named the talk metal content estimation. But all right, so yeah, but why didn't I call it tons or volume estimation? And if you look at for the word tonnage online for a definition, you might find a definition that contains a direct reference to the word tons, perhaps. But I'd like to, take us to the JORC and the SAMREC codes as these apply to our industry, as opposed to, like the shipping industry, for example. So if we look at the JORC synonyms and similar terms to the word tonnage, you'll find quantity and volume, which I don't really think is necessarily synonyms in themselves. But let's look at the intended generalized meaning. An expression of the amount of material of interest, irrespective of the units of measurement, which should be stated when the figures are reported. And then SAMREC, that second bit is, volume may be substituted for tonnage. But it's the JORC intended meaning that I prefer, because it kind of offers something that may mean either volume or weight, or maybe rather mass, if you want to be perfectly scientifically correct. But if you just take this JORC piece in isolation, it almost offers you the freedom to report your amount of material on any unit you like, as long as you just report that unit that you are reporting it in. So when I named my talk tonnage estimation, I'm referring to the amount of material, and it is going to be related to volume and to weight. And then I'll use the word estimation. I'm not going to talk about specifically like the process of estimation like in a block model, but rather like the approximation basically of how much material of interest we would have in our project, and some of the factors that might affect that answer. The content for today is we'll just first look at why it's important and how it fits in with this event's theme. And then I chose three factors that can affect this tonnage or amount of material estimation. And these are by no means, the only factors affecting final tonnage figures. I mean, I'm not including anything like variograms and density estimation parameters that will also affect tonnage. I don't know, I'm curious to know what Jeremy's talk will cover, perhaps maybe some of those items. And, I also don't cover something like geo loss. So be it known or unknown, that's eventually applied to your reported figures. So this is just, I decided to choose three topics, one that I found recently that is not necessarily implemented correctly always, and then one that I recently saw that quite shocked me, and then also the grade one is quite interesting. So let's get into it. I should probably say at this stage that the applicability of this talk is more like, think of like a precious metals deposit, as opposed to, bulk metals or hydrological type deposit like lithium and brine, for example. It's, there's such a wide variety of types of deposits, and even, not necessarily even between commodities, but even within the same commodity, you get such a wide variety. But, for today, let's consider a common hard rock deposit, maybe, like a precious metal like gold. Okay, so why is it important? Why is tonnage important? And let's look at these two equations, if you will. It's density times volume gives you weight, and weight at the end of the day times your grade will give you metal content. And these affect your mine and plant design, and then together with the metal content that will feed into your project value. And obviously, I know it's not as simple and limited, to that. But this is what's, kind of how it ties in my talk with the event of the theme of the event, and how it's relevant. And I know what you're going to say in terms of, mine and plant design. I know it's not directly like just weight, it's think of, the shape and the size of the domain will rather directly speak to the mine design. So, shape and size will maybe firstly be the volume, and then, perhaps you can think of the plant design will be based on, the amount of material. But let's just, consider for a moment, the way that the plant capacity and production is reported. It's the tons per period of time, for example. So for today, we will consider the following variables affecting our tonnage: is the density, the volume, and the grade. And perhaps I should say not only grade, but grade estimation as well. So let's proceed and see how we get to that conclusion. Now, the first one is density measurement. And like I said, I was part of a project with some old data, and I just saw that, perhaps this isn't necessarily common knowledge, and it could be a good reminder for people to apply good practice when doing density measurements. Now, density measuring is usually very simple, and therefore not much effort is applied. And the Archimedes method is the most common method used in core yards. And so I think something like what Jeremy will probably say is we often have these intricate quality assurance protocols and quality control procedures when it comes to our assay samples. We choose labs with accredited methods and being pedantic with QC samples and calculations. But then when it comes to SC samples, it's just given to the junior on site, no quality control, no verification. And why is that? Because in the previous equations, you saw how the density will also eventually feed into the metal content calculation and eventually project value. Now, I'll admit, obviously the variance in density values is much smaller than the variance in assay values usually, like a typical deposit where grade doesn't affect your density, like an iron deposit, for example. But back at variance, if you consider the coefficient of variation of grade, that can easily be like, for example, 10 times higher than the coefficient of variation of density. So, with the lower variance, your error variance will be lower with your estimation, etc. So, but still, it can be incorrect, and it can feed an incorrect value into your calculations, and especially when it comes to a highly weathered or porous material. So let's just for a moment consider how the grade is reported by the lab. It's in this example, we take something like grams per ton. Now, when they weigh the sample to do this calculation, they use a crushed dried weight. So that weight does not account for or is affected by poor water content in the sample because it was dried. So that weight is just rock particles, if you can consider it like that for a moment. And therefore, if we want to align the metal calculation of our mineral resource with the calculation of grade by the lab, we once again have to use the weight of the rock particles, excluding water. Now, the whole volume of our resource, that's easy. Obviously software can easily calculate the volume of a wireframe, or for example, when you have a block model, it's easily just the sum of the calculation of the volume of each block, the dimensions of it, and then the sum of it. So that's an easy calculation. So now we have to get an appropriate density that we're going to multiply that to get an appropriate rock particles weight of this resource. And so the ideal would have been if you had now a core sample, you can dry it, you can weigh it, and then you somehow did a volume measurement by looking at like water displacement, for example, like that volume calculation. But that's not practical. So, that's why we use the Archimedes method. And now, one way to think of it, via a detour, basically, is if you weigh the sample in air without drying it, you're including water into the weight, not just the rock particles. Therefore, you have to dry the sample. And now you also have to seal the sample before you put it into the water. So if you don't seal the sample, you're not, water might ingress into the potential or pore spaces, and then if we were to measure the volume water displacement volume, then that wouldn't have been the same anymore. Now that's not what we measure, but maybe you can think of it this way, that if you seal the sample and there's pore spaces, that would contribute ever so slightly to the buoyancy of the sample and therefore weigh less, and then that will increase the dominator of the equation, therefore decrease your density. So, the point of this slide that makes a very simple concept actually unnecessarily complex is just, this is the way I kind of argued it for myself to understand it, and hopefully it, it can remind someone out there, because I've seen how this is not necessarily always practiced to try and seal the samples, and also to perform quality control. I've seen some ridiculous density measurements in databases. So, there also needs to be some quality control and verification. Moving on to domaining, when Nicole initially invited me to talk at this event, I wanted to actually talk just about the Parker challenge. But unfortunately, I couldn't get Rio Tinto to make the data public for me to analyze it and make my own interpretations. The Parker challenge was organized as part of the Mineral Resource Estimation Conference that took place in Australia in May this year. And unfortunately, since I don't have the raw data, so of the results, so I will only cite and credit Scott Dunham here for the content of this slide. So the Parker Challenge made this exploration drill data set available to anyone wanting to participate. And the task was to model, estimate, and classify a mineral resource. And then the panel looked at the person-to-person variance between these mineral resources of the same data set. And the results were actually quite upsetting, I would say. And you can see, the type of variance you have in the results. And this grade tonnage curve is of all the entries, and it doesn't even cover the full extent of tons that were reported. Now you can see that if you consider the average grade, I don't think, unfortunately, I don't have the actual numeric results, but I don't think the variance between the average grade was as high. There is still a variance, and you would expect that because obviously people use different estimation methods and parameters and different top cutting and etc. So you would expect that, but if you consider, but it's not as high as the variance in tons. And then, so if you eventually consider the variance in the metal content, which is these figures reported here, that metal content variability is more affected by your tons than the grade, I would say. And therefore, it's, I would say, like the domaining played a much bigger role than geostatistics. If we look at this exercise of person-to-person variance. So domaining is such an important thing, and how it can affect our metal content variability. So I'm going to, I want to give another example of June Cohen and Ron Reed, an article that they wrote that was, it's actually focused on a specific method of implemented during geological modeling, which is not my focus here. But the gist of the introduction, actually, just of the article, is that the downgrades of mineral resources are more often than not due to overestimation of the domain rather than due to incorrect modeling rather than grade through incorrect geostatistics. And the point for today, therefore, is just, how we as resource geologists should be mindful of this during geological modeling phase. And what I include here is a little animated image of June, one of his articles. And what he did was he took an exploration. I'm illustrating it because we, at Earth Lab, we don't use the same software as he used for this for this exercise. So, I couldn't reproduce it in the same way. because of the different approaches in modeling. But what he did was he took a data set with a known model. Then he took different sub-selections of these drill holes, as you can see, like the drill holes used change every time. So it's a larger set, and he took sub-selections. And he allowed the software to model with default settings. So just the isotropic default modeling setting. And he looked at the variability in the volume compared to the known volume. And that's where that range came from. And then, yeah, it just shows how he actually applied his geological mind, set the software settings to with intent, with his understanding of the geology. And then he had a much lower variability in volume. And another example of Jin is where he modeled a simple folded structure, created a fake data set basically to support that model. And then he took the data set and then tried to remodel the actual structure. Where in the middle you can see actually, once again, he set the software settings with his understanding of the geology, where you can see it kind of, it resembles the original model. But here you can see what a mess up it is if you just leave the software to its default settings. And yeah, the point is that the quickest way for us to go wrong with tonnage estimation, subsequently metal content calculation, is incorrect domaining. And I think one of the first things where that can happen is just with the software that we use. And we shouldn't just let the software run its course. I think software have made modeling and resource estimation much faster, but that can also just mean that we're getting to the wrong answer much quicker if we don't properly steer the software. So we really have to dissect and understand our total geological picture before modeling, and you can't just input the data and let the software run its course. Consider all these different geological factors, and once also with when you create a domain, lithological versus a grade-based domain, you really have to understand, for example, your mineralization controls when you create a grade-based domain. And yeah, so domaining plays such a significant role in our tonnage estimation. And so there's a question that we can pose, that should the mineral codes not perhaps put a restriction on the distance beyond drill holes that you are allowed to extrapolate for your reported mineral resource, regardless of what your geophysics and surface mapping tells you? So I did a little bit of an exercise. If we take 3 hypothetical resources, that covers 500 by 500 meters, 1,000 by 1,000, 2,000 by 2,000, and just the actual drill hole grid. If you take it out to the outside drill holes, this is the coverage area, 250,000 million, 4 million square meters. And then if you have let's say, for example, just for argument's sake, a 10-meter thick constant thickness of 10 meters and a density of 2.8. This is the types of the amount of tons that you would have in that domain. It's the number of drill holes. That's just to put forward to put it into perspective for you. So these things don't affect now the calculation, because if you take a constant reef thickness and density and grade, then the extrapolation exercise that we'll do is just based on area. But first, let's just if we oversimplify, if we take 2 or more drill holes intersecting the same thing, you can deduce that there's continuity between them. But if you don't have a data point on the other side, then whatever you infer on these sides is that it's less supported. And even if you, for example, have geophysics or mapping, and we apply our geological minds, if you model something outside, then it has not yet been confirmed by drilling, for example, that offers an actual confirming sample. And so what you can see from the graph is that this is the the smaller one, the 500 by 500, 2000 by 2000 in red. And then this is on the x-axis, the amount of meters that you extend your domain beyond the outer drill holes. And what you can see is that even in a large resource, if you go to 100 meters, so even like if you have a 200 by 200 meter drill hole spacing and you extrapolate to half that drill spacing, 100 meters, you have a large increase in domain size compared to what is known, to up to the outer drill holes. And whatever you model outside of those drill holes is up to the modeler's discretion, and it will differ between people, and that's where that person-to-person variance comes in. I would even go as far as to say that you'll get whole number percentage differences just depending on how much you zoomed into the geophysics map when you digitize that perimeter string, perhaps. So, would limiting the resource strictly to the outside drilling data points be too conservative, because that's our last known data point. And if we clip our domain to that, or snap it to that, then at least there's less person-to-person variance. Maybe it's too conservative. Maybe is it the status quo, or is it my geological intuition that makes me say that? Probably both. But I think there's space for that question as to, how far do we extrapolate beyond our known data points? And I think with what exercises like this and the Parker Challenge and what Jim Cohen did was, it should just remind the project owner and investor that resource estimation remains estimation. It's not an exact science. So, we knew with the Parker Challenge there would be person-to-person variance. I just don't think we knew how much it would be. And then moving on to grade and grade estimation. And let's see what I meant by that. If the average grade of the estimation domain is not economical enough, a cutoff grade will have to be applied on a block model level to achieve that desired average grade. That's very straightforward. And so for the grade estimation factor that I'm bringing in here, we're going to assume now that we're going to apply a cutoff grade. So, and we're going to see how smoothing affects that final tonnage. So in an interesting article by Edward Isaacs called The Kriging Oxymoron, he cites Dani Krieger on stating that the preliminary prerequisite of all resource estimators is the elimination of conditional bias. So if we consider the equation for checking conditional bias through the slope of regression, then we will never have a perfect, we know for a fact that we will never have a perfect correlation between the estimated and the true block rate. So this will be that correlation coefficient, that will be less than 1. And if we want a perfect slope of regression of 1, then we know that our variance in our true block rates will be higher than the variance in our estimated block rates. And therefore, if these distributions differ in that way, then we know that the estimated grades are smooth because the variance is higher in the you can also think of it as the variance in the samples versus the variance in the block rates. And it's easy to see how it physically happens during estimation. The minimum number of samples that we use during estimation is usually set to a number greater than 1. I don't really use something like nearest neighbor where you just take one sample. So it's usually like an interpolation and a weighted average using more than one sample. Now, if you estimate a block, for example, using a sample with the lowest grade, like the minimum, and then another sample with a grade that's higher than that minimum, then that interpolation or that estimated grade will be something in between those two grades, obviously weighted based on the distance and okay, we won't go into things like variograms, but now that block does not equal the minimum grade of a sample. So the same principle applies to the maximum, and as you interpolate, then your lowest values your minimum in your blocks are higher than the minimum in your samples, and the maximum in the blocks is lower than the maximum in the samples. So you can see in this chart is, it's like that green one, for example, where you have a higher variance, you know, the distribution is much higher, wider. And then if you consider the mean here in the middle, as you basically smooth more and more, it just tends more towards the mean, and your variance, the distribution is not as wide anymore. So you have a much higher minimum, a much lower maximum. And you can even think of it as, you know, in principle, if you take, for example, like a domain where you have this perfect one single block, and that, so you're only going to have one grade estimate, and that centroid of the block is at equal distance from all the samples, and use all the samples in the estimate, then that block will have the average grade of all the equal weighted average grade of all the samples. So, and then, you know, if you work that principle backwards to smaller and smaller blocks, then you just see that principle in reverse. Now, the level of smoothing also depends on various factors, such as your variogram nugget and range, your number of samples that you have, and how they distribute in 3D, and your search parameters, block dimensions, etc. And then I want to illustrate another principle, and this will, I think some of you will be familiar with the volume variance effect. If we imagine ourselves with this block of ore with, you know, or not necessarily ore, just material, and with specks of nuggets of gold in it. If you were to use a spoon to mine it, and you were able to, you know, when you mine it with a spoon, you have very, very fine selection or selectivity. You will be able to exclude waste from your ROM pad with, you know, spectacular control. Actually, you will be able to have a load that is close to pure gold, basically, and then a load that is pure waste, no gold. But now, if you decrease your selectivity to something like a bucket size, and then after you've applied a cutoff grade to decide what is economical or not, then you'll see that now you include some, it's inevitable to include some waste or barren material inside this ore load. And then also, unfortunately, there will be some gold in your waste. And then we can, you know, exaggerate the principle even further. You know, it's just with more waste perhaps included in your ore loads, and more gold in your waste load, just because of that lower selectivity that you have, or a less fine selectivity. And yeah, so increasing the smallest selective mineable unit, basically, even further, will, like I said, it illustrates this principle. And then, you know, finally, if you were to have a selectivity of this entire block, then that the average grade of this block will just, or the grade that you mine is just the average grade of this block, and no longer, when you have finer selectivity, then you have like a sample or load with the average grade of that block, and then this one will have a different average grade. Yeah, so we'll see how that, you know, the volume variance and smoothing and everything ties together to illustrate basically a similar principle. So what I did was I just created like a fake data set to do an exercise, and it was like a perfect log normal distribution, and with 8,192 samples. And you can see the minimum, that was the minimum, and the maximum. Now, just, you know, ignore the actual values here of the maximum. It's just, you know, that's the way that this distribution was set up to illustrate the hypothetical principle. So, and then I smoothed it a couple of times, and then, you know, after 4 phases of smoothing, you can see now I only have, when I say smooth, it's basically, you can think of it as in a way as, you can imagine instead of taking a 1 meter sample down your core, it's now 2 meter samples. Or you can imagine in a block model sense of, instead of having a block with a 10 by 10 by 10 meter dimensions, now it's 10 by 20 by 10 meters, for example. It's like just double the size basically, and then you double the size of the block again, or the sample length. So you have to take the average between these samples or blocks. So that's, and then because you take the average between them, you no longer have that minimum and maximum, you have something between, and that's how it's smoothed. So that's why what I mean by smoothing is you reduce the number of samples, and each sample is the average of 2 samples of the previous data set. So you maintain the same mean of this data set, but as you can see, you increase the minimum and you decrease the maximum. And we can have a look at a theoretical grade tonnage curve of such a data set where you have, we started with something like, let's say, 10 million tons. And then as you start to apply a cutoff grade, the first cutoff grade that was applied was higher than the minimum grade of the data set. And then obviously that's why you immediately start to have a reduction in your tons. So that's just for this example now. And then you obviously, because as you exclude the lower grade samples from the start, you have an increase in your average grade that will rise as you apply a cutoff grade. Now, this is the original unsmoothed data set. And then if we consider after 4 rounds of smoothing, you can see this shift in the tons and the shift in the average grade. And that is because now the first couple of cutoff grades basically tested was still below the new minimum of this new smooth data set. So for the first couple of cutoff grades, you don't have a reduction in any tons because there weren't any samples at those grades. And then at some point you start to have a drop. And then obviously the same with the grade is also shifted from the original one. Now we'll have a look now at the metal content, because even though you have more tons at a specific cutoff grade, you have less a lower grade. So you have less. The previous data, the original data was less tons but a higher grade. So we'll have a look at the metal content, the effect it has on metal content. And then just to illustrate the extreme of the principle is let's say, for example, we've smoothed it out to one single sample. You throw in all your core samples into the same sample, or you throw in your mineral resource as one single block. It's not like a block model with 1 million blocks. It's one single block. Then we just have the average of 5.32 grams per ton. And then if you apply any cutoff grade lower than that, there's just no reduction in tons because you haven't reached that grade yet. And then as soon as you apply that cutoff grade of the mean, then you have a reduction in, like a total reduction. There's nothing left anymore. So that's just, as you can see how that initial one is the shift that tends towards this final extreme. Now, I think this one is perhaps important to have a look at, is the metal content. So if you just take then that average grade times the tons at each cutoff grade, the blue one is that initial unsmooth one. Just ignore this jagged artifacts that gets produced here at the end, as you can consider this general trend of that. And then that red one was smoothed, I think, 4 times, and then the yellow one was smoothed 6 times, and then this was the extreme. Like I said, it's smoothed up down to one single last sample or block. And now what you can see here is that at low cutoff grades, you might even end up, compared to like the original one, you might end up with even more metal content at the same cutoff grade than the original. Same cutoff grade compared to the original one. But then at some point, then you actually don't have the same metal content anymore, and much less. And it's especially important when you consider a cutoff grade that's above the mean compared to the effect that it will have when the cutoff grade is below the mean. So, you know, we can compare like the level of selectivity or, you know, the change in support and the level of smoothing. We can compare all these things with one another because, you know, you kind of illustrate the same thing, and there's a similarity in the effect that it has. So we need to be mindful of the effect that what a cutoff grade tested on a resource model, for example, has on if you later on apply cutoff grade applied on a ore control block, like a grade control block, which has, you know, much closer drill hole spacing and much smaller blocks. So what I wanted to illustrate here, and I know it's just a lot of numbers, so it's difficult to make sense of it. But if you consider so the yellow one is the unsmoothed, the original data set, you know, much finer resolution of samples, or you can think of it as much smaller blocks. And then this one is larger blocks or longer samples or less selectivity in your mining. If you were to apply a cutoff grade of 1.5 grams per ton, you would end up in this case with still with 9 million tons, whereas with the unsmooth, then you would end up with much less tons, but with a much higher grade compared to this one. And if you okay, so the one example that I actually wanted to show is aiming for an average grade of 9 grams per ton. So if you were to apply a cutoff grade of 4.1 grams per ton, that's just, you know, it's kind of just what the data set offered me to aim for something that's very close to one another. You apply 4.1 grams per ton cutoff grade in the smooth one, and you'll end up with much less tons than at an average grade of 9. So if you were to aim for the same average grade, the cutoff grade is now much lower with the unsmoothed. And if you then take that same cutoff grade and you now go back and apply it to the smoothed one, like for example in this case, you no longer have a 9 grams per ton average grade, you have a much lower one of 5.35. Or if you consider the one that you applied at a smooth, so let's think of this one as the resource model, the one with the larger blocks. Then you aimed for 9 grams per ton. You perhaps said that's what we need to achieve for the resource to be economical. So we need to apply 4.1 grams per ton cutoff. But now eventually when you get to the mine and you have the ore control, the grade control block model, it's much more data points, closer spaced, smaller blocks. If you were to apply that exact same cutoff grade now, then you will end up with a much higher grade. So this is where it's important, you know, and I don't want to go into you know, the topic of dispersing variance, like the between block and within block variance. But this volume variance effect is very important to consider when you have this initial resource that you estimate, and you apply a cutoff grade, and then you okay, obviously I realize there's a lot of steps in between and of all the studies that's going to be done eventually before you actually start to break ground. But it's just, you know, it's a reminder that it's very important to consider your cutoff grade. And then when it comes to your what you report as your resource eventually, you have to be mindful of what was the level of smoothing and how this might affect, like we saw in that metal content graph, like it can actually affect your metal content. It's not just like the amount of tons that you actually report, but that's what I initially wanted to illustrate, like how it actually affect your tons or the tonnage of what you report, depending on what your grade is, what is going to be economical for the project, and how you apply the cutoff grade. And then the level of smoothing that took place, how that's going to affect that final tonnage that you report after applying a cutoff grade. So that's in conclusion, what we can just go back to the first initial, like the first factor that I mentioned, like the density measurements. think it's important that we remind ourselves that the estimate is already going to be erroneous. We know that, there's that famous saying of all models are wrong, but some models are useful. We know that it's just an estimate and it's not going to be perfect. But therefore, because we know it's going to be erroneous, we need to minimize that errors around, at every step that we can. And, for example, like the densities, something that is what I've seen can sometimes be neglected and rushed and regarded as an afterthought. And I don't think it should be. You need to, whatever you can do in your power to minimize that error, you need to do that. And, by following good practice. We saw how domaining has this massive effect on our total tonnage. And I think it's just a reminder for resource geologists also not to be overly aggressive with how far they extrapolate. You have to understand this geological setting and understand the full geological picture. And then also, I think it is in some cases important for the resource to be reproduced, and especially if you recreate the resource with additional data, then that you for example, when it is increased, then it's increased fairly and at the same basically ratio. So we need to devise a method basically that can be recreated downstream. And that's why I said perhaps and I'm not saying that it should, but perhaps we should just limit the domain to the outer drill holes and nothing further. Even if we know that it continues, we can't report it until we haven't confirmed with drilling, as an example. Yeah, and I think then lastly, it's very important to understand the purpose of that specific block model, because there's a difference between a resource block model and the stage at which you consider it, compared to a grade control block model and the stage where you consider that, and how it's informed by data and the level of support. So and we need to understand and be mindful and understand that effect of the support and smoothing, what effect it can have when we apply a cutoff grade. All right, so that's my talk. Thank you very much. And I'm actually not sure, because I didn't check my watch what time I started, so I'm not sure actually if I am on time, because we deviated. Oh, I see, 48 minutes. But maybe I think I started my presentation on my computer slightly early. Tanya, is there time for questions? Or
yes, indeed, we have plenty of time for questions. So if anybody has question, comment, please raise your hand. There's a comment and a question in the chat box, and the comment is made by Tlotlo, and I think so many people would agree with this, that it is important to have the proper basic knowledge and not rely on software. The user must control the software and not the software control the user. You need to understand what you are doing. And yes, I think you brought that out, and I couldn't agree more with it.
Yes, no, definitely. I know that there's such awesome developments in the softwares, and I don't mean to single out or pick on a specific one. I think something that I know that one specific package developed was this almost like this automated process of the whole model just gets updated as soon as you input a new drill hole. The whole thing gets updated, and even downstream to the estimation part of it. And although it can save you a lot of time, I think it's very dangerous just to let the software run its course by itself. I think we need. That's where, discussing the whole topic of how AI is going to replace geologists, I don't think we're there yet. Okay, that's a whole nother topic. But yes, no, we need to understand the geology and our software, and then the user should control it, definitely. But sadly, because some of these softwares are so user-friendly and so quick, sometimes the user input is kind of neglected, and the software is relied on too much, I think.
Okay, we have a question from Sophie. From slide 5, what QC program would you recommend during density testing?
Yeah, that's a good question, and a difficult, and it's not one that I actually considered before, while preparing this talk. I think, you know, there's obviously difference between quality assurance and quality control, and you should, as part of the quality control, I think there's a component of verification. And you know, with assay samples, we have that, or assay as analysis, grade analysis. Then we have usually CRMs, which, you know, this certified reference material gives us almost like a known. We know what to compare our samples to be accurate, for example. Or then we can split the same sample in at different stages in to create duplicates, and then we test precision. Now, I wouldn't necessarily say that you're going to test something like contamination in density measurements, but you can do the same at least, for example, for precision testing, that you can have two samples that are the same, that you test, and you see how close these two samples actually the density values that they produce. And then you can remeasure certain samples, and to see, obviously that's basically like a replicate. And what I definitely think is that you can what should be done is that you shouldn't just input into the database the weight in air, weight in water, and then let the software calculate it and you move on. You should actually see what the outcome is, because, you know, I've seen in databases density values of negative density values, so density values of 200, or, you know, even density values of above 10 for just normal rock, you know, and that's unrealistic. So you know, as part of that verification steps, that should also be implemented. Now, I can't give a specific. I'm not sure if this is referred to like a program, like a protocol or a campaign, or a program like a software program where you do the stats in. But I think it shouldn't be. I think density measurements is just often regarded as an afterthought, and it's just rushed by someone with less experience, and it's never checked really, and it's just input put into the database without really verifying whether these measurements were accurate. I hope that answers the question, but I think definitely Jeremy's talk, I'm excited to hear his talk. Maybe he will actually give more insight into that step.
Thanks, Marius. There is another question. From considering the cutoff grade slide, I see that there is an inverse relationship between tonnage and grade. How do we go about selecting a better grade at a minimum tonnage? Or do we work knowing a grade that you're aiming for?
Yeah, so the inverse relationship in the grade tonnage is as you start to apply cutoff grade, to say that we don't want to send anything, let's say, for example, below 2 grams a ton to the ROM pad, to the plant, because that's not going to be processed economically. So then we say, all right, well, anything that's below 2 is going to go to waste. So then we reduce the tons. But then now, because we've taken out those low grade tons, that's how the average grade of the remainder of the tons then start to increase. And that's going to, obviously there's a lot of considerations. It's not as simple as just to say, all right, what's economical, in the sense of, you know, you take all your OPEX and you say, what, okay, well, how much metal is in that material of a particular grade, and then if all the mining and processing costs would be covered by the metal that you, or rather, actually, like you're probably obviously going to mine it, but the processing cost, would that be covered by the actual revenue that you would generate from that material? So your minimum or that cutoff grade will, I think the first obviously question that will be asked is what is economical, but then there will be other practical considerations as well. And let me just make sure I understand the full question. How do we go about selecting a better grade at a minimum tonnage? Do we work knowing a grade that we are aiming for. Yeah, we are going to, and then obviously we also have to aim for the average, like that whole thing of mining to the average grade, because you don't want to just mine all your high grades in the beginning and pay out all the bonuses, and then at the end of the life of mine, then you sit with all the low grade. So you want to try and aim for average grade, and that's how you also have to consider like the distribution of your grade in your deposit and the mine design. So obviously you want to sometimes go for something that's easy and to pay back your capital in the beginning, but obviously you have to still honor that mining to the average grade. Do you know where we can access the methodology applied by Hot Chili, who won the Pocket Challenge? No, I would love to also know. Actually, maybe we should contact them. Was Hot Chili, was that? I know that it was like a team that won the Pocket Challenge. I don't know exactly, but they said that there was a clear, the comment that was made by one of the people on the panel, maybe it was Scott Dunham himself, that was like, it was a clear winner, so it wasn't even difficult to see who the winner was. And then obviously they said that, that's why they excluded some of the outliers, because it was clear that some of these entries should perhaps not have been, considered. But anyways, that's the first of its kind, and they say that they will continue creating these challenges, for us to also understand a little bit more about the variance in what we do.
So Matt is our next speaker. Just a bio of Matt. Matt is a resource geologist with more than 40 years of experience in resource and reserve estimation and reporting, project development, and geofinancial analysis. He's worked for major mining companies such as Gold Fields, BHP, and for mid-sized companies as well. Additionally, he's worked as a rock engineering researcher, as a mining analyst at the JSE, and as a consultant. Matt is a competent person in most major precious metal-based metal and bulk commodities, having worked on projects and operations across the globe. He's chaired the SAMREC and SAMVAL committees, is a fellow of the AusIMM, SAIMM, and the GSSA, also an ex-president of the GSSA, of the GSL, and is a registered natural scientist. He's currently an associate executive consultant with Snowden Optero, and he's based in London, UK. And with that, thank you, Matt. I'll hand over to you.
Thanks, Nicole. And I've certainly enjoyed the presentations this morning so far. So thanks to you and the organizers for putting together such a lovely program. This changes direction a little bit. We're going to talk evaluation, and the quantity we're going to talk about is zinc. This is certainly one of the most interesting projects I've done in the last couple of years, from various aspects. Firstly, zinc, I found a very interesting commodity. Secondly, having a look at the resurgence of mining in Italy that's taking place, and we'll talk a little bit about that and why it's taking place. And then thirdly, a Valman valuation is quite a bit different to a SAMVAL valuation, which is what I would normally be used to. There are many similarities, as there are with all the valuation codes around the world, but not as many similarities as with the JORC and SAMREC world, where there's a lot of commonality. There are more differences in the valuation side. And a lot more is open to interpretation as well. A lot more is open to the view of the competent valuator, which is called a bit different in the Valman world. So I've chosen to use this valuation in Northern Italy because it does have a number of interesting aspects to it. And I'll take you through those aspects and why it turned out to be a very tricky valuation, but also an extremely interesting one. So we'll go straight into it, firstly by introducing the Valman Code. The latest edition is 2015. It's the Australasian Code, and it is supported by, obviously, the Australian Institute of Geoscientists and the AusIMM itself, and it's binding on those members. As per SAMVAL, it provides the fundamental principles, it provides the requirements and recommendations for a public report. It fits very importantly within the Australian regulatory framework, the big one being the Corporations Act, so one needs to be reasonably aware of what's in the Australian Corporation Act, and various ASIC, so that acronym is the Australian Securities and Investment Commission. They have a number of regulatory guidelines, and they're called numbered with RG in front of them, and especially RG 111 is the key one to keep in mind when doing a Wellman valuation, and also the ASX listing rules. And it is a companion to the JORC code. So that's the sort of the Wellman code. Let me just point out a couple of differences, because you would need to know the differences if you're doing a SAMVAL valuation. Firstly, to start with the last one, Wellman is not co-branded with JORC, as it is between SAMVAL and SAMREC. So it is a separate code, it's a standalone code, and it requires the provision of, in the public report, of a technical section, which is not just a summary of the JORC report, but it has additional requirements as well. And that makes it quite difficult to comply with, because especially if there are differences between the JORC report and the technical report in the public report itself. Secondly, it's not a requirement of the Australian Stock Exchange listing rules. So as SAMVAL is fully incorporated in Section 12 of the Johannesburg Stock Exchange listings rules, the SAMVAL, the Wellman code is not incorporated in Section 5 of the Australian Stock Exchange listings rules. That makes things very tricky, because enforcement of the Wellman code is not through the readers panel, or the way that the South African governance of the SAMREC and SAMVAL code is done, but is quite different. It is largely through the professional bodies, the ARG and the AusIMM, and very importantly through the ASIC. They are the key enforcers of the Wellman code, and the ones that you need to satisfy in any Wellman public report associated with any transaction or listing. I suppose technically, though, in terms of its valuation itself, it's pretty similar to SAMVAL. It does recognize the same approaches, and it does recognize the same way that the valuation is done, in particular, the acceptance of the concept of highest and best use. In SAMVAL, a person writing a public report, valuation report, is called a competent valuator. In Wellman, you are a specialist, and a specialist must be competent, similar to SAMVAL, have at least 5 years of recent and relevant industry experience, at least 5 years in technical assessments, and an additional 5 years of experience in the valuation of mineral assets. That's a bit of a variation on SAMVAL, where it doesn't require that additional 5 years. C is the same as SAMVAL, member of a professional organization, and there is international reciprocity, as there is in the JORC and SAMREC and CRISCO world. D is really a given. You've got to know the code, you've got to know the JORC code, you've got to know the Corporations Act, and as I said, you have to know what's in the ASIC guidance notes and in the Australian Stock Exchange, or any other thing that might be relevant to the public report. In addition, they are quite prescriptive in terms of what should be in the public report, and as opposed to SAMREC and SAMVAL, which are not as prescriptive, they outline exactly what they expect to see in the public report. This is one of the lists that you will get in SAMVAL, in Wellman, and you need to comply with all of them. ASIC will be absolutely ruthless in terms of ticking the boxes if you don't comply with each and every one of the requirements in the Wellman code. I've seen Wellman reports rejected on very, very minor issues, a little bit like 43-101 in the Canadian context. If you don't have a certain section in your report or you don't comply with the section, it's going to be sent back to you to actually fill in all of the issues there. Valman operates in a very similar way with, as I said, ASIC and the professional bodies providing the main governance side of things. Let's go into how you do the valuation. All the codes internationally recognize three approaches to valuation. So the first one is the market-based approach, and this is one that we might be most familiar with. This is similar to house pricing, for example, where you compare your house to similar houses in the area with a similar size, plot size and a similar house size to get a market-based valuation. Same thing happens in mining. You compare your project or your operation to similar projects or operations around the world. And I'll take you through that in some detail on because that's the approach that we followed mostly in terms of this particular valuation. The second one, which also you probably be most familiar with more than the market-based approach, is the income approach. And that's your standard NPV-based cash flow analysis of a project or an operation. And that can be used under certain circumstances, particularly for operating assets and particularly for projects that have completed a pre-feasibility and a feasibility study. And the third one, which tends to be used more in sort of early stage exploration projects, is the cost-based approach. So that's how much you've actually spent on your exploration. And there are various ways of modifying that expenditure. And I'll show you what we did in this particular case in terms of multiples of exploration expenditure to take into account the prospectivity or what you have actually discovered in terms of your exploration. And the guidance note 13, I didn't mention it, but the International Financial Reporting Standards Guidance Note 13 contains a bit more detail on that. I don't find it that useful, so I didn't mention it earlier, but that is something that you can look at if you're doing evaluation itself. Let's turn to the example that I'm going to take you through. This particular project that I was asked to be involved in was the subject of a hostile takeover. It's a listed Australian Stock Exchange company called Altiman, and their major shareholder, VBS, launched a hostile takeover of all the shares in the company at a certain valuation price. The Altiman approached BDO in Australia to put together a defense of this because they didn't feel that the valuation and that the price being offered was sufficient in terms of their understanding of the total value of this project. And it's not just the project, it's all the other assets that they had in Italy as well. I'm just talking about the project itself, but the valuation was on all of their projects. And BDO approached Snowden to do the technical report or the Valman report on the evaluation of this of Altiman. And as I said, I'm just going to talk about the valuation of the Gorno project itself, which was the zinc project in northern Italy, but we did value all the rest of the assets of the company, mostly early stage exploration. This report that we issued is an appendix to the BDO report and can be found on Altiman's website if any of you want to go there. Obviously, a Valman valuation is fairly complex, and there are some things that I'm not going to cover in this talk due to lack of time. But if anyone wants to have a look at certain aspects of how we went about the valuation, it's all transparently published on that particular website in, I think it was June last year. Yeah, our report's dated June, I think it was published on the website in June. And I think, as I mentioned, the Snowden report, I think, is Appendix C to the target statement issued by BDO. Okay, let's move on. So the background to the public report, as I said, in May, Altman received that unsolicited offer to take over the whole company, which implied an offer value of approximately 37.2 million Australian dollars for the company. BDO engaged Altman and to prepare the target statement, and Altman engaged Snowden, as I said. So this presentation from now on will really just be looking at the valuation of the Gorno zinc-lead project in northern Italy. Where is the project? Well, you might have asked the question. I haven't heard of any mining in Italy at all, and you would be absolutely right. There's very, very little, if any, hard rock mining going on in Italy, not because of lack of prospectivity, but largely because most of Italian hard rock mining was conducted by state-owned enterprises, which in the early 80s, following on the increase in the oil price, started to focus on oil and gas exploration and closed all of their mines. This particular mine was operated on and off for about 100 years by the Italian state-owned oil enterprise, and they closed it, I think, in about 1983. Excuse me. And it hasn't reopened yet, although it's been the subject of a number of feasibility studies, and it's currently undergoing a final feasibility study at the moment. It is located, those of you know your Italian geography, I don't have a broader scale map. It's in the report if you want to see it. There's Milan, so it's northeast of Milan. There's Bergamo, and these are what's called the Bergamasque Alps. Those of you know Lake Como is sitting over there, and then that's one of the big lakes east of Bergamo, and about 20 kilometers north of Bergamo, accessed by very windy tar roads. I must say I was quite surprised the first time I went there on how slow I had to go to actually get to the project. And you'll see a picture in the next slide on what it looks like. Very, very built up. You can see the whole valley crisscrossed by roads, less so once you get into the Bergamasque Alps themselves. What does it look like on the ground? So this is a picture of the project area. We're going to show you two pictures. This one's looking eastwards, and the reason why I'm showing you this one is this is the bed and breakfast that I stayed in when I was doing the project investigation. Beautiful, beautiful summerish. It was in May area, very green, very popular amongst hikers. The big thing that I noticed, though, and it came to me a number of times afterwards when we looked at the project as a whole, was at the first night that I was there, and I looked out over the village. You're in a little village called Oltre del Colli, looking at another little village nearby called Zambla Alto, was the lack of lights in the houses. I queried this the next day, and what's happened in the countryside in Italy, and it's a common throughout Europe, is the urbanization that's taken place. So it's not just from rural to the cities, but it's also from the small villages to the cities. Only in this area, only about 30% of the houses are actually occupied. And they're beautiful houses. They're used as summer homes. If anyone wants to go and visit there, you can pick up either a bed and breakfast or a long-term rental for next to nothing, because the houses are just open. That has a direct impact on supply of labor, supply of services, supply of light industry, all those sort of things when one was looking at developing a mine. We took that into account in our valuation. So looking at the mine itself, so this is a Google Earth image. Can I just go back 2 slides? Can you see the two peaks over here? So this slide, this is looking north towards those peaks. And there you can see the two peaks. The town where the project is based is called Ultra Il Colli, and the ore body is situated underneath part of the town here and part of the surrounding mountainside over there. It does extend extensively all the way to the east, as I'll show you in the, I think in the 2 slides to come. As I say, historically mined extensively, and one of the investigations I did afterwards, purely for my own interest, was to look at whether this was actually mined in Roman times, and I put together a geoheritage paper which I published in Geobulletin in September last year on speculation that this is where the Romans got their zinc, based on comments made by Pliny the Elder. So anyone who's interested in geoheritage and those sort of things, please go and have a look at that paper. This is just close up a little bit. So if we're taking a photograph just of that area from the main office of the company, the exploration office is sitting over here. That's the Belvedere Valley. There's your 2 peaks over there. And this ore zone is a little village, and most of the ore body sits down below here at depths of a couple of 100 meters, but it does outcrop on surface. And where it outcrops on surface, the zinc and the lead is in oxide form, and that's the informal mineral called cadmia, which was mentioned by the Romans. Okay, moving on. So just keep those pictures in mind. There's Ultra Il Colli over here, and the network of roads. These little red lines are roads. You can see the winding nature of the roads going up the mountainside, and coming down the other side. All the Altman lease areas in yellow, and you can see the main lease area encompasses this area up here, with a secondary lease area down at the bottom of it now. It's about 10 kilometers between the 2 lease areas, and you can see the historical mines scattered throughout the area from all the way on the east, 10 kilometers away, to where the most of the activity is taking place in this part of the lease area. The little black areas, I'm not sure if you can see them well, are the areas that have been mined out underground. And there is a connection between the 2 lease areas called the Riso-Perina Tunnel, which goes all the way from this area, which is called Riso-Perina, all the way into this area over here. I went underground at as many places as I could, from this area into this area over here. And there is a very, very nice little mining museum situated in the Riso-Perina area. And they do take visitors underground, and we went underground in that to the mining areas down there. We didn't go through the tunnel that joins the 2, although it is apparently accessible. If we move on, just a little bit of geology. I'm not going to talk too much about it, but you're in the Cisalpine Alps, and there's Milan, and there's Bergamo, and you've got multiple thrust faults trending mostly in an east-west direction, and at the same time folding the rocks up into anticlines and synclines. The project area is in this little green area over here, and relatively deformed in that area, although there are thrust faults, so you have repetition of the main ore zones, and you have different host areas, rocks that host the zinc and lead ore. So let's look at what those look like. You can see most of the host rock is limestone. This is a very high-grade zinc. The zinc itself is mostly light-colored, very similar to pairing in South Africa, that honey-colored zinc. The host rock would either be limestone or black shales. And you can see the various ones there. You can see some intense deformation adjacent to one of the shear zones in the of the ore body, which cut the ore body. Here you can see the deformation that's taken place with limestone, mostly calcite, being the whites and occasional quartz. The three main ore types are in the black shales, in the Brino limestone, and the Pian-Braco, mostly black shales and limestone. So those three ore types, but generally tabular ore bodies, anything from a meter to a couple of meters thick, generally flat lying, occasionally a little bit steeper, and reasonably okay in terms of the estimation. Very tricky though, where you do have slivers or parts of barren country rock within the ore bodies themselves to make sure that you're actually modeling those correctly. Okay, I think that's enough on the geology. Let's turn to the valuation. So we're looking at that northwestern part of the ore body. Again, the leaf area shown in yellow. You can't see all of the boundaries, but you can see most of it there. The red area is where mineral resources indicated and inferred have been defined. The purple area is where exploration targets have been defined, and the white area is where there's no exploration, although in many of it there are areas which have been mined historically in the past. So the key thing is to make sure that the valuation covers all three areas. We were restricted from using a cash flow approach because although a pre-feasibility and feasibility had been completed in the past, the company itself had decided to put the project back into concept study for various reasons, mainly from an infrastructure point of view. And so without a recent, established, completed and accepted and published pre-feasibility level study, we couldn't use a cash flow valuation. Although we had the cash flow valuation available, the NPV had been done, we could view it, but we couldn't actually include it in our report, and we couldn't actually refer to the numbers that the NPV had come up with. So our approach was to value the red and the purple on a comparative basis and the white on a comparative basis, but in a slightly different way. Okay, and then so let's have a look at the resource basis. So it's indicated and inferred, a very high-grade deposit, 8 million tons at 6.8, and lead at 1.8, and silver at 32 grams per ton. So as you can imagine, a very high-grade ore body, much higher grade as the Mississippi value type, but pretty similar to other MDT types that I've worked on throughout the world, but certainly on the higher grade level, higher than many of the others that I've looked at. The exploration targets were done in accordance with JORC and SAMREC, so reported by range 17 to 22 million, 8 to 10% zinc, and 1.9 to 2.4 lead, and 19 to 23 silver. A key aspect which you can have a look in the report is how to convert all of these to a zinc equivalent and what price to use for the conversion of that zinc equivalent. And we go into that in a lot of detail. Zinc is a very unusual commodity in that, well, I suppose many commodities do exhibit a lot of volatility in price, but zinc certainly does exhibit a lot of volatility. And the selection of the price used for conversion to zinc equivalents is absolutely critical in the valuation, and that absolutely took up a lot of our time when we were looking at that. I'm not going to go into that in too much detail. The key to the valuation was the comparative transactions. So we used Standard & Poor's Capital IQ database. It is an excellent database. You can certainly select or come up with as many comparative transactions as you like based on the criteria that you put in. We, I think, looked at something like about 55 different transactions as our population, our initial population that we looked at. And then from that 55 population, we selected out a number of individual comparatives, which we felt were the most similar to what we were looking at in Gorno. So you can see some of those are marked green over there. And let's just go to the next one. So these are the comparative transactions that we looked at. I'm not sure if that's all. But from the 53, we chose 12 transactions as being the most similar, with our transaction criteria being within the last 5 years, with zinc being the primary commodity, and preferably with lead and silver. So in other words, multiple commodity deposits. Preferably with the existence of historical mining, preferably underground, although we did include one open cast mine, and preferably at the pre-development, development. And I think there were 1 or 2 operating mines but hadn't been in production very long. This is critical, and the most critical thing in the Wellman report is to make sure that the criteria used and the selection of which ones we used and which ones we discarded is absolutely transparent, because this is probably the area that's most open to scrutiny and most open to challenge, because it is fairly subjective. So the critical thing, as I said, is the criteria and being able to demonstrate that the selection of your comparatives meets those criteria. And if you look at the numbers here, we did the number 1 separately, so that was the resource area, number 2 separately, and number 3, 4 was the Risa Perina area, and 5 areas separately. And why I mentioned these numbers is because I'm going to show you in the next table what the valuation is for each of those particular areas. Critically here was obviously the area that has the highest confidence resource, which is area 1, was only discounted by 10% for resource uncertainty. That was a subjective decision because there were no measured resources. The exploration targets were discounted by 90% to reflect their low confidence. And then we also, for the areas where there was no resource definition, we chose 246 property deals on moose pasture, and from this population we had 17 comparative transactions. And so that was just a straight property deals without any resource definition in any of them. So this is the bottom line. So if you look at the areas, sorry, I haven't got the numbers there, but these are all the different areas that we're valuing. So that's the mineral resources, that is the exploration targets, and these are the balance of the property. So the valuation we came up with was a low of 46, a high of 72, and a preferred value, which was our mean of $59 million. Wellman and Samwell both require a check valuation of your primary preferred valuation. In this case, we used a multiple of exploration expenditure based on the land valuation, or based on the amount that has been expended, which was 18.7. And again, we decided on a range of the multiple of exploration expenditure factor of these in terms of the literature. And Andre van der Merwe, I don't think he's online, has done a very nice paper on this, tend to range between 0.5 and 5 and 10. We looked at comparative valuations, and we chose a minimum of 2 and a maximum of 4, which just by chance gave us a low of 37 million, a high of 74 million, and a preferred value of 56 million. As you can imagine, and I'm just going through your heads right now, there is a certain amount of subjectivity in the selection of, adjustment factors. And as always, you just have to be able to say, this is the reason why I chose those numbers. Having said that, I've reviewed a number of other valuation reports where different valuators would choose different numbers. Each of them are as valid, and it is a problem in the valuation. That's, I won't say a problem, but subjectivity in the valuation needs to be accepted and fully explained transparently in the report. That's it, and just a couple of conclusions. So I would, if anyone has done a Valman valuation, they would recognize what I'm saying here. You have to be meticulous. You have to comply with each and every clause, and that does take time. It's not a quick exercise. Besides the valuation itself, just complying with all the clauses is onerous. You've got many and extensive databases out there. Standard & Poor is just one of them. A number are held proprietarily by certain companies and are used very effectively in their valuation analyses. Some companies, and in particular in the gold and coal industry, they tend to use more rather than less comparatives when it comes to comparative valuations. When you're getting into the base metals and bulk metals environment, and especially in the Australian environment, they tend to try and limit the number of comparative valuations to those comparatives that are most similar, and not try and go for as many as possible. It's just a way of approaching it. There's neither a right nor wrong. But as I say again, it just needs to be transparent. And then the last comment I make is that when you're valuing a property, you do need to value the whole property. So as I showed you, in our valuation, we valued the area where resources had been defined, the area where exploration departments had been defined, and we valued the area that had not yet undergone exploration but was still prospective. I've mentioned the GeoHeritage paper, so please have a look at it. It's in the GSA Geo Bulletin if you're interested in that sort of thing. But with that, I'm hoping that we still have time for a couple of questions. I know I'll probably have gone over a bit, but hopefully we still, overall in the program, are still on in time. Thank you very much.
Thank you, Matt, very much. There definitely is time for questions. So if anybody has a question for Matt, please go ahead. Don't see any hands. Think maybe from me, Matt, just interesting on these databases, these comparative databases. I mean, I would be interested to, to hear from you in terms of the information that they contain there. I mean, where would they get that information from? Is that things that are possibly listed on the market or that type of thing, or where would they get the information from?
So it's all publicly available information. There are analysts like at Standard & Poor. They have an army of analysts who put it all into a standard format. One thing I didn't mention was that once you've got your comparatives, it's still absolutely worthwhile to go back to that transaction itself and have a look at the documentation that was issued at the time and go through it. That is quite a time-consuming process. So also that helps when you're only looking at 12 transactions, because each and every one of them will take you half a day to really understand. And if you're looking at 100 transactions, it's very hard to go through all of them, for example. But all the information is available in the public domain. Standard & Poor Market IQ is on subscription, and it does cost, I can't tell you how much, but it's not, the information is publicly available, but the compilation of that information does tend to be on prescription by Wood Mackenzie or S&P, and there are a couple of others out there that do provide this sort of information. One of the other things, Nicole, that we had to look at is if the transaction is done at a certain price, like a zinc price, whereas the current price the current transaction has been done at a different price. And zinc is a case in point, and I would say platinum probably as well, in terms of your basket PGEs. Do you need to adjust the transaction value to reflect the current price so that you comparing apples with apples? We had a long debate on that, and we ended up doing an adjustment. It didn't make a lot of difference, but we did.
Very interesting.
Yeah.
There's a question in the chat: how many databases are out there? I mean,
oh gosh, good ones. It's hard to say. I think 4 or 5 maybe that are publicly available, and then there are a couple in-house databases in certain companies. I think Venman, for example, have a very comprehensive gold and coal database. But I wouldn't be able to put my finger on how many. There are not a lot of good ones. I mean, of big comprehensive databases. Yeah, I'm guessing, but I'd say about 5.
great, thank you. Okay, here we have some more questions. First question: why Altiman chose the comparative rather than income-based?
In terms of the rules, you cannot use an income-based approach unless a pre-feasibility minimum of a pre-feasibility has been completed and signed off and published. They had completed one, but then because they went back to concept study, that invalidated the previous pre-feasibility that they had completed because it was now out of date. And so in some ways they shot themselves in the foot, but there was absolutely nothing we could do about it. We had to use comparatives.
Okay,
good question though, very good.
Next one: with regards to the selection of comparative projects, is there a minimum number of projects that can be considered to be representative? It's a fair assumption to say the more you have, the fairer or more complete the assessment. That's the question.
It is a question for debate, and we debated it long and hard. There are, I would say, 2 camps. One which says the more the better, and the other one which says the more comparative or the closer your selection is to the project or operation that you're valuing, the better. I initially looked at the whole 53 transactions, and then we brought it down to 12 based on our criteria. It didn't make a lot of difference, to tell you the truth. I can't tell you the exact numbers, but if I'd used the whole population, I don't think our final number would have been different. The range would have been wider, though, much wider. And that's probably a good thing. But when you're looking at an operation which has got indicated and inferred resources, and you're comparing it with a project that has not yet defined indicated and maybe earlier has inferred, you are going to get a wider range because the market won't value that particular project as much as it values a project with indicated and inferred. And then if you include a project with measured, the market would give more value to that. So you have 2 schools of thought, and I think in some ways it's a bit commodity specific. I like, when I'm doing a gold or a coal valuation, I like as many comparatives as possible. But in some commodities like less, and we decided on less for this particular one. But also a very good question. And worthwhile bringing that up with the SAMVAL committee and seeing, what the range of opinion is there.
Okay, good stuff. Kwiti, you have your hand up. Go ahead.
Thanks, Nicole. Hi, Matt. I would
Hi.
like to know if you perhaps know about evaluations based on evaluations. So, for instance, after a few years, evaluate what made sense in an historic evaluation and what did not, whether it was market prices that changed or perhaps looking at impairments after a few years. Why did the evaluation why was it predictable or correct or not? please?
So that's a very good point. So the best valuation of a listed entity is its current share price, its current market capitalization. But then what you're doing is you're not only valuing the project itself, you're also adding on all the corporate overlays. In other words, how much debt, equity, fixed, etc., etc. How that changes with time depends on how the market views that particular project. If you have a dormant project that has no prospects of being developed, the market's not going to give it much value. But if you, like this one, are in the process of doing a techno-economic study to bring it to account, the market is going to give it a lot more value. So your most efficient value is the market. However, what we do in Valman and Samval valuation is called a fundamental valuation. It's what is the intrinsic value of that particular project. Now, that intrinsic value might not change dependent on whether you've done a full feasibility study or not. It might still be the same at pre-feasibility or at feasibility, although it does tend to change a bit. But your value that a buyer will put on it does increase dramatically according to the standard S-curve when you go from exploration to development. You know the standard S-curve. If you plot NPV versus time, you go up the steep part of the curve as you are doing your pre-feasibility and feasibility study. That's when you create the most value. So, I mean, that's the whole game that everyone's in exploration and development, really, to try and do that and get bought out by a senior in the process. I'm not sure if I answered your question well, but I tried.
Yes, thank you. But you were just making me think that would you change an valuation based on the company that asks you for it, so that you actually consider the company's size, or there's so many different things to consider? Would you change it?
So a valuation would normally be commissioned by a financial institution, not by the company itself. So on this particular occasion, I wasn't commissioned by Ultimate to do the valuation. I was commissioned by BDO. BDO in turn were commissioned by Ultimate to prepare a defense. I wasn't influenced in any way by the company, or whether I liked it, or whether I thought it was a good or bad company. I was at all stages in doing an evaluation. You have to, in your own mind, try and say, I am independent, I am independent, I am independent. And if your numbers come up with if you come up with a number that the company doesn't like, just tough. In this particular case, my valuation was higher than what the market, what the offer was for the shares. And so obviously the company didn't like it, and they recommended to reject the offer. If my valuation had been lower, they might have come up with a recommendation to accept the offer. But yeah,
thanks, Matt. There's two more questions. We're running out of time a little bit here, so I'm just going to quickly go through them.
Okay, thank you.
Taryn asked, you had cash flow from the previous pre-feasibility study. Did it compare well with your other valuations?
Yes, it did. Just coincidentally, it did. I can't remember the exact number, but it was within 10% of the comparative valuation. It gave me a lot of comfort that we were on the right track, that the industry is fairly efficient in terms of the value that it puts on transactions. You know, if you think about it, you're not going to just go out and buy a project. You've got a team of people who are geologists and all sorts of technical people and financial people who are going to determine the value that you put on that project. And that's the efficiency of the market. You've got a whole bunch of people that actually are there. It's a whole industry determining value. And it is, I believe, fairly efficient. Sorry, there was one.
Yeah, last one. So Bat just asked about the regulatory environment in Italy. He said he heard it just took 11 years to get an exploration license in Italy for the first Spar mine. Does this not affect the evaluation?
Absolutely. It's horrendous. We did discount a lot of where they had not In fact, I think all of them we had licenses, and you can go onto the Italian database and you can go and see the licenses and that sort of thing. But for this particular one, the mining license was subject to a long list of requirements that they wanted. And that's part of the reason why we discounted the valuation. Italy is not used to mining. It hasn't done hard rock mining in 20, 30 years. Getting environmental permits, exploration licenses and mining licenses is not going to be easy. But there seems to be a groundswell of movement towards getting back into hard rock mining, especially in terms of what the European Union describes as critical minerals, where they would like to produce those minerals themselves instead of bringing them in from outside the EU.
Okay, so our next speaker is Taryn Flitton. Taryn graduated from the University of Wits in 2000 with her honors in geology and started her career at the SA Gold Mines for AngloGold Ashanti. She has a plus 21-year career with AGA, including 10 years corporate experience, directly leading and managing governance aspects of resource and reserve estimation and reporting in accordance with SAMREC, JORC, and the SEC SK 1300 requirements, as well as coordinating and managing independent audits, reviews on operations and projects globally. The growth span of responsibility for a single operational level to oversight of the governance reporting on all AGA's operations and projects globally. And Taryn is currently also the vice chair of the SAMREC committee. So thank you very much, Taryn. Looking forward to your presentation.
So good day, everybody. I presented 2 weeks, I think, ago at the SIMM. We had an SK 1300 sort of workshop for dual listed companies. And this is just going a little bit into how AngloGold Ashanti manage the governance and reporting processes, and specifically how we have streamlined our efforts in minimizing the workload for our qualified persons, competent persons for SAMREC, qualified persons for SEC SK 1300, and really just how we can minimize their workload so that they are still compliant in reporting with 2 code requirements. I'd just like to acknowledge my fellow authors working at AngloGold Ashanti, so Marcelo Godoy and Adrian Elliott, who are involved in setting up our process for reporting and helping manage the process. I think with big companies like AngloGold, we always have a disclaimer slide. So just, this is our company disclaimer. I think what's more important is at the bottom here, this presentation is really provided for general information purposes only. The opinions or views in this presentation don't represent the official position of AngloGold Ashanti. They're my opinions and views, and this presentation does not constitute any legal advice. So just a bit more about AngloGold Ashanti, and what we've done on the right here is really given a 22 at a glance. So as at December 22, where AngloGold Ashanti is in terms of its key metrics. AngloGold Ashanti is an independent global gold mining company with a geographically diverse, high-quality portfolio of operations and projects and exploration activities. We work across the full spectrum of the mine value chain, from exploration, where we establish and maintain a pipeline of economically viable and competitive projects, to developing long-term mining operations, all the way through mine processing, refining, and the sale of the product, to rehabilitation and mine closure, to ensure that we minimize the impacts our activities have on our communities and the environment. And importantly, you can see we have a resource base of around 131 million ounces and a reserve base of 30.4 million ounces. So AngloGold Ashanti is working to regain its cost competitiveness within our peer group through the optimization of our operating assets and by introducing newer, lower cost production sources to our portfolio. So here we're showing all of our properties. Our greenfields exploration tenements will cover approximately 9,500 square kilometers of highly prospective ground in 6 countries. We have advanced projects in Colombia, as well as the United States, with the district scale technical assessment of geological potential ongoing in Nevada. And then we have our operations, and they span across 7 countries, namely Argentina, Brazil, Guinea, Ghana, the DRC, Tanzania, and Australia. So for AngloGold Ashanti, exploration is the foundation of our business, and I'm sure it's the same for most mining companies. This slide really just shows exactly why we're so excited about the potential within our portfolio. We're in the midst of a program to increase investment in our reserve development and brownfields exploration, and thereby increasing the reserve conversion, extending our reserve life, and improving mining flexibility. So over the last 3 years, we have made cumulative additions of 12.2 million ounces of mineral reserve at a cost of roughly $67 an ounce. Our reserve has grown 26% over the last 6 years, and we've managed in 2022 to replace the depletion again, which is one of our prime goals. So just a little bit more about mineral resource and mineral reserve governance. AngloGold Ashanti understands the resource and reserve governance to be the management framework by which the mineral resource and the mineral reserve is firstly estimated, then managed, and how we report it. So the framework is there to provide assurance to the board and investors of the integrity of the reported mineral resource and mineral reserve. And this is the primary asset of the company and upon which investment decisions are based. It ensures that the process is auditable and defensible. It's in compliance with the regulatory codes, the company's standards and guidelines, and that reporting is transparent, appropriate, timeous, and reliable. So we have a resource and reserve leadership team that facilitates and manages the process by setting the standards of quality and the requirements to be in compliance with the reporting codes. This includes providing annual updates to our internal standard and guidelines for reporting, training of our competent persons to ensure all are aligned and report accordingly, as well as ensuring regular audits and reviews for all the properties. The mineral resource and mineral reserve governance process and framework for AngloGold Ashanti was presented at the previous SAM Codes conferences in 2016, as well as 2022, where we actually went into the application of the process, and it was also published in the SIMM journal in 2017. And I've given a link there to the journal if anybody wants to follow what we've been doing. So an example of a standard set by AngloGold Ashanti's resource and reserve leadership team in our internal guideline is the classification of mineral resource categories. In this guideline, we state that the mineral resource classification is to be based on a definitive and auditable process and is to adhere to the 15% rule. And I'll explain what that is a bit later. What this does is it ensures consistency between the properties within the AGA portfolio. The process of methodology of classification is always at the discretion of the competent person, and they need to defend it against their peers. Techniques such as relative covariance, conditional simulation, or even an empirical reconciliation-based approach may be employed. The relative confidence in sampling, drilling, and quality control, which may impact the confidence, should be considered. And really, in tangible terms, the classification is based largely on the drill hole data and considers that drill hole density or spacing. So to illustrate this, I'm showing figures 1, 2, and 3. So 1, 2, and 3. And these were modified from Parker in 2014, and I've given the reference below. And here we show various drill hole spacings and corresponding classification in comparison to the ground truth blast hole spacing of figure 4. So here is the ground hole based on the ground truth based on blast holes, which is a 7x7. Now the ground truth figure is only there as an example showing what the ore body could look like if samples were more closely spaced. So when we compare figure 1 to figure 4, you can see that we have fairly widely spaced drill hole data here, so 75 by 75. And really, this density of drill hole data is insufficient to confidently interpret quality, grade, and continuity. So you can see that this higher grade portion is very clearly defined and doesn't really represent the ground truth example. So you're not really seeing the high grades coming through, and you have therefore a low level of confidence resulting in an inferred resource. And then as your drill hole density increases, so here we've moved from a 75 by 75 to a 50 by 50, so closely spaced, we can start seeing that high grade ground truth starting to actually be better represented, but still not as well represented as the ground truth. So the sample locations are more closely spaced. The continuity of your high grade is better, but it's really just at an assumed level in terms of continuity, quality, and grade, and therefore it's at an indicated level. And then really moving to the more closely spaced, so the 25 by 25. So here we actually seeing that high grade is fairly well represented compared to the ground truth example, and we have a much higher level of confidence, and so therefore we can confirm that it's a measured resource. Now, competent persons are responsible for demonstrating through reconciliation that their classification system conforms to the 15% rule. So what is the 15% rule? Simply, this rule really links production volumes, and it's from Parker in 2014, links the production volumes and the level of confidence expected, such that, so when we start looking around reconciliation and we ask our competent persons to confirm through reconciliation that their system is conforming to the 15% rule, a measured resource must be within 15% of the quarterly tons, grade, and content estimated, at least at the time. So this figure 5, we're showing at on a quarterly production volume of 10 quarters need to be within those limits. Okay, so the 9 out of 10 quarters, so 90% of the time, you need to be within those limits of your tonnage, grade, and contents estimated. Then for figure 6, we have then on an annual basis, so within the production volume of an annual or the number of years, the indicated resource must be within those 15% limits of the annual tons, grade, and contents estimated. So 9 out of 10 years, it needs to be within those limits. For an inferred then resource, the annual error will be greater than the 15% limit. So in other words, more or less than 9 out of 10 years will be within the limits, and that would be an inferred mineral resource. So this is just an example of how we, in terms of our framework and our guidance and our training, we ensure that everybody is complying to the 15% rule. Moving on to really how we would then assess that. So as part of that governance framework, we then have set 3 lines of assurance. So this ensures that risk factors that are identified or are identified and managed, and there's reliability in the estimated resource and reserve. So just starting on this level 1, where we've called it, we own and manage our risks. So level 1 assurance includes self-assessments by our competent persons on all technical work at key stages of the estimation, generation, and reporting. It can't be said enough that you need to be able to check your work, and you need to be able to see that you can defend it against your peers. So these are basic checks involving verification of numbers and processes. As part of that same level of assurance, we then, for any updates of the resource and the reserve, so generally we will update annually, our business units, technical services, or project teams, depending on the property that we're looking at, must then ensure that a peer review is completed. So this is where the competent person is then able to defend their assumptions and the process that they've followed to their peers. So this could be technical peers or it could be indirect supervisors, but there's some form of independence. So it's not the people doing the work, it's one level removed. When we move to the second line of assurance, this is where we oversee risks. So it's really including any internal review, ensuring compliance to our standard, our reporting standard, and that all the processes have been followed. So these reviews are done for any updates, again, on resource and reserve, and completed more or less annually. So depending, obviously, if it's been updated, then we'll do it. And we're really following through the standard and the guideline to make sure that the processes followed are according to those standards. The level 3 line of assurance is really around an independence assurance line, and it includes the external audits of processes employed for both resource and reserve. So these audits are conducted on average every 3 years per property, unless more frequent period is required, or if it's not material, it's not deemed material. Through all these lines of assurance, you need audit trail documentation. So we compile an internal audit trail documentation that follows from the start to the end for the resource and the start to the end for the reserve. It includes handover between the resource and the reserve teams, one from the resource to the reserve, and then back from the reserve to the resource for your exclusive mineral resource calculation and estimation. And so we provide this as evidence on the assurance process and findings. We have audit reports. So through this process, as you being reviewed by your peer or by your corporate team or by an independent assurance team, there'll be reports that are detailing any findings or any recommendations. And from that, we'll close out those reviews to ensure any critical items are addressed and that recommendations are considered for improvement opportunities. So we close, it's like a closing of a loop. So that's just an example, 2 examples of how we have managed the governance framework within AngloGold Ashanti. So I put this slide together I did an APCOM presentation in July this year, and it was really trying to talk around how we've managed as a company that's dual listed the 2 different codes. So we listed on the Johannesburg Stock Exchange as well as the New York Stock Exchange. And in 2022, we were required to comply with both, therefore, SAMREC as well as SK 1300. So many of you might have seen that AngloGold Ashanti has moved its primary listing to the New York Stock Exchange. And for 2023, we're finalizing that understanding of being primary listed on the New York Stock Exchange and therefore secondary listed on the Johannesburg Stock Exchange. But for 22, we were primary listed on the JSE and secondary listed on the SK. Now, SK doesn't really recognize the JSE, but the JSE does recognize primary listing on another stock exchange, and therefore will allow us to report what we're reporting on that primary stock exchange. So really, I'm just showing a high-level comparison of how we, as AngloGold Ashanti, is currently understanding the requirements of the 2 stock exchanges. Looking at the first point here, section 12.13 of the JSE listing requirements is the minimum contents for annual reporting, where reporting is in accordance with, as we know, the SAMREC code. SAMREC is closely aligned with the CRISCO, which sets to standardize market-related reporting definitions for resources and reserves. Now, SK 1300, which is the regulation SK, and known as SK 1300, which is the SEC subpart, is effective from the 1st of January 2021. So effectively, we reported the last 2 years using SK 1300. And although it's not a CRISCO code, it is closely with CRISCO-based codes in terms of definitions. There are some differences, though, and I'll note these in the next slide. So SK 1300 now permits the disclosure of exploration results and resources, where previously Industry Guide 7 did not really recognize these or allow the reporting of these. Then with the JSE requirements, companies listed need to disclose detailed information listed here for annual reporting. So if you go and look at the JSE 12.13, there's a list of requirements. And I've just listed a few. So exploration activities, geological setting, type of mining, history, etc. With SK 1300, the disclosure set out in items 1300 to 1305. So that's that SK 1300 subpart. And it details all the information to be disclosed for all properties in the summary disclosure. So there's a summary disclosure portion. And then for the individual property disclosure portion, you only need to disclose for the material properties. So that would be typically in a Form 20F for a foreign private issuer and a 10K for a domestic registrant. So then if we're looking at this third point, as for SAMREC, the SK13 requires the QP details to be disclosed, as well as written consents to be published in the form of context in which it appears. Except with the SK1300, you actually have to publish those consents. SK1300 is now aligned with SAMREC in allowing QPs to use prices that provided reasonable basis for establishing estimates. So with Industry Guide 7, it was more around you would have to use the 3-year trailing price. Now you can actually, as long as you can justify your price, you can use whatever price. So before we had differences, now we're more aligned with the two requirements. And then just lastly, and I guess, this is really a high level, is around SAMREC Table 1 and Technical Report Summary. So for SAMREC, the Table 1, which is reported on an if not, why not basis, must be disclosed for first-time reporting and where material changes have occurred for significant projects. The requirement for the Technical Report Summary, and we'll go through what that's more stricter requirements, and it's more lengthy than a SAMREC Table 1 completely. It needs to be filed as an exhibit to the Form 20F and 10K for each material property only. So at the previous conference 2 weeks ago, we discussed material properties and what that assessment would be. And although it's not the same level of detail, we understand that. You could see that from this high level that there were a lot of similarities in terms of content to be disclosed for the dual listing reporting requirements. So we went through the individual items of the SAMREC Table 1, and then we went through the individual items of the summary disclosure for SK 1300, the individual property disclosure for SK 1300, as well as the technical report summary. And we started matching where we started seeing similar instructions of what needed to be disclosed. So we acknowledge that with streamlining, we didn't want to oversimplify or lead into non-compliance with the reporting requirements, but we wanted to reduce the duplication and workload on our competent persons. So while there's a significant overlap in content between listing requirements and codes, SK 1300 technical report summaries in terms of the content that needs to be disclosed. And understanding these reporting differences remains key on how these impact on consistent and equitable reporting for the multiple jurisdictions. So importantly, AngloGold Ashanti, looking at the differences here, we already disclosed exclusive mineral resources as part of our annual JSE disclosure. So we have a process that we've set in terms of our standards and guidelines in terms of how to, and really a minimal change in our existing process for resources, reporting resources. I think the biggest issue we had was really splitting, so you couldn't total, measured, indicated, and inferred for SK 1300. You would have to total, measured, and indicated as a total, and then add inferred additional to that. So that's a very SK 1300 requirement. We're mindful that SK 1300 states the technical report summaries do not include large amounts of technical or other project data, or information, but there is the requirement for inclusion of specific technical and financial information, which isn't typically included for JSE reporting, such as economic analysis, including annual cash flow forecasts based on an annual production schedule for the life of the project, as well as mine closure planning. So materiality is certainly not new to reporting of resources and reserves, and is one of the principles in all CRISCO codes. So the SEC state that both qualitative and quantitative factors when assessing material properties must be considered for all stages of the property. So you need to consider your exploration properties and even your properties that are in closure, and all your commodities. So you need to really consider everything when you're looking at, is a property understanding. First, we did like a first time reporting kind of in 2021, and then we adjusted our understanding of what material properties were, and looked at what material changes are. And so we've developed a process in the company, and we review that annually. Competence is one of the key principles of the reporting codes, and again, no different for SK 1300. Qualified persons, however, take on significant liability with SK 1300. And while they can state under specific circumstances the information that they rely on from the registrant, which is, I think, one of the last chapters of the technical report summary, they may not disclaim responsibility from a third-party specialist. The role of the QP in this process is critical. And so we at AngloGold Ashanti really do focus on our competent persons and how we appoint them, and if they've got sufficient experience, and if they registered with the right recognized bodies, and that their experience is in the commodity that they are essentially an activity that they are performing the work in. Technical report summaries at AngloGold Ashanti are compiled in-house by employed competent qualified persons who are reliant on technical specialists, and we list the technical specialists as contributors within the reports. Our QPs accept overall responsibility for the resource and the reserve, and specifies in the technical report summary which sections they've prepared. The qualified persons also provide their own opinion throughout the technical report summary. So these are really key pieces that we've seen with the technical report summary. And then lastly, although SK 1300 focuses on developing projects, operating mines still need to be reported. And we've seen this throughout. So where they want information that you would typically disclose for a project, but for an operating mine 20 years down the line, it seems a bit ridiculous to start reporting that information from the start again. So it's a balancing act of the level of detail that we've put in. For exploration stage projects, it's important that an initial assessment, which is essentially a concept study level, is required to support the disclosure of a resource. And like SAMREC, a minimum of a PFS or FS is required to support the disclosure of a reserve for development stage properties. Properties that are managed by JV partners that are Canadian 20 F filers still require a technical report summary to be filed. So we have a JV partner that is Canadian 40 F filer. They get the recognition that they are multi-jurisdictional disclosure system, so the MJDS, they recognize. However, we cannot use that technical report summary. We actually had to compile our own technical report summary for that. So these are all the items that we've picked up through the process. So with the challenges in understanding and reporting the requirements for multiple stock exchanges, it became increasingly important to consider or continue using our process-driven approach at AngloGold Ashanti and adapt the requirements of SK 1300 to additionally manage the company's resource and reserve information within our existing database reporting system. It remains critical to ensure the integrity in the data compiled from sites all the way up to the group level, and the reporting is still transparent, appropriate, timeliness, and reliable. So our process-driven approach is underpinned by that governance framework that I spoke about earlier, and that setting of the requirements of the standard of quality of information at a group level, and again through the assurance process. So we have a secure cloud-based database solution, and this really adds to providing assurance that the information is secure, fully auditable, and has a single source of the truth. It is important that there remains a clear segregation of duties within the system, with users assigned a unique sign-on, and where the process for capturing is workflow driven. So everything is within a workflow. You can only do what's assigned to you for that specific level of work. And it's got a full documented chain of responsibilities and sign-off. So the benefits of such a system mean comprehensive validation can be built in and managed with ease in consolidating the information to the level of detail required for the reporting and to the applicable stock exchange requirements, especially if we dual listed in this case. So information and documentation such as letters of consent and technical report summaries can easily be stored and easily accessible years later. In streamlining and the opportunity of streamlining, we aim to minimize that additional workload and reduce the reporting burden of these additional requirements that were from SK 1300. And so we aligned as far as possible our SAMREC to our SK 1300. We implemented a project within the database that we had, and we ensured that the QPs only capture the information once within a single data repository, such that the system then was able to generate the documentation for applicable codes and regulatory bodies, allowing really consistency in reporting and compliance, ensuring the compliance. So shown in the bottom left here, we're currently using K2Fly's resource and reserve reporting system named R-Cubed, which integrates 3 workflows that we've set up within our system to capture the information. So here you can see we've got a personal details workflow. So that's all the information on the qualified or competent person. So it's their education, their qualifications, it's their experience. So it gives their positions and what they were actually responsible for. It gives who they registered with. They're able to upload their proof that they are currently registered with that specific organization. And so it just gives that extra information that we use in our reporting. The resource and the reserve workflows is really where we capture our mineral resource, our exclusive mineral resource, our below infrastructure information. We reconcile, so we reconcile year on year, what happens to the resource, what happens to the reserve. Our mineral reserve workflows, modifying factors that have been used in the conversion of the resource to the reserve. And there's a lot of other additional pages that we capture. And then lastly, this integrated R&R workflow, which is where we combine SAMREC Table 1 and SK 1300 all into one workflow. So it goes line for line through, and the competent persons then essentially answer the instruction. But it takes all 3 of these workflows and combines it. And then from the system, we can pull out 4 various reports. So we can pull out a SAMREC Table 1, a technical report summary, an individual property disclosure, and what we used to use in our annual JSE reporting. So it's important here, you can get various reports and any system, I think, Marius mentioned it earlier, whatever you put in a system, it will spit out. What's important though is that the QPs need to review this export. So they need to review it and ensure full compliance. So we have additional guideline documents. So once you get your export, you then look at it and you say, have I answered every single item? Where the advantages are is whatever you've stated for a technical report summary, and it's a combined field, that same item will be stated for SAMREC. This entire process is managed internally within the company, and it just really limits the rework of information. So I'm just going to show, I think I've got 3 examples. So here we are exporting an annual report text, which is what we've used in the JSE. So you can see the input actually looks like the SAMRIC table 1. So we go line for line through. And here, this is the export of our introductory table. So it produces it in a format, it's PDF or a Word document, I think. And each item, so it will go through the history, the legal aspects and tenure. You can see it's in paragraph format. When we compile the information, we don't compile it in bullet form, we compile it in paragraph form, and we don't compile it as if we were just doing a SAMRIC table 1, where we, just refer to this portion of the competent persons report. We actually answer it as in the instructions. So if it says detail the quality control, we wouldn't say go to section this of the competent persons report. We would detail the quality control processes that we have. There's another example of a paragraph on exploration and projects, and then a map. And lastly, it produces tables that come straight out of, and all of these tables, the figures, the information has been signed off within the system. So it's been signed off by the content person, it's signed off at a high level by the business unit, then by our corporate team, and then lastly by myself. So the export of the technical report summary, so what that would look like, it actually comes in a table format in Word. And once we formatted it, so we take the tables away, it starts looking like a technical report summary. And we do a little bit of additional work to it. So we add a signatory page. I think that actually comes into the template, as well as the consent. And then we're able to add the content, because each of the fields are already headings in the output. So this is the second last slide. We have a fully integrated system of reporting spanning across all our operations and projects, where we input all the required information into a securely captured and stored, which is securely captured and stored for multiple commodities using multiple assigned quality competent persons, as well as technical specialists. We're able to manage our governance and reporting process for the reporting of the resource and the reserve by ensuring that the data, as well as then the information related to the resource and the reserve, has been captured, reviewed, and signed off by various competent persons within the company, all the way up to the group level. And we have the capability to generate multiple output reports at various levels of detail, compliant with the relative stock exchanges and the code requirements. And again, I'd just like to highlight, we don't just export and publish, we export and review, and it goes through extensive review. But what we're doing is we are applying a very consistent process across all our properties. This process, as I mentioned, was managed centrally and internally, and is fully auditable. So you can see who has added information to the database and what they've changed. And yeah, we just undergo that final review. So on my last slide, it's important to remain flexible within any reporting system so that we've developed. So we continue to monitor SEC correspondence to our peer companies on SK 1300 reporting, and we adapt our disclosure as our understanding develops. What's key is transparency, materiality, and competence, which are our key principles in compliance, and we don't forget those. So we make sure that we are transparent about our reporting, and that we, especially when it comes to materiality, and we have a whole rigorous process around competence. The disclosure must not exceed the parameters set out by the requirements of the rule. This is specifically for SK 1300. So they don't want you to over disclose from other regulations and codes. So that was a process that we had to manage, because a lot of the information that we would disclose normally for SAMRIC, we had to hold back for SK 1300. And the use of these reporting platforms, such as R-Cubed, but additionally, platforms such as Workiva WDesk, simplifies complexities of reporting and compliance. So it then helps you or assists you with filing on the SEC. And it starts becoming increasingly a necessity for dual-listed companies. We continuously support, guide, and educate our qualified persons in all aspects of reporting requirements, including their roles and responsibilities. So we keep them trained up. We keep them aligned with what our standard says, what our guideline says. We go and visit them at their mine sites, and we ask them to take us through their processes so that we can ensure that they are aligned. Our QPs need to be empowered to deliver results, not only in compliance with the codes and regulations, but also to deliver outcomes consistent with all stakeholder expectations. And that's what we keep key to ourselves. All right, that's it from me. I think I was like on 40 minutes. I'm sorry if I took too long, Nicole. Yeah, any questions?
See your hand, Matt?
Yeah, Ms. Taryn, that's an excellent description of what you guys do. One of the questions I had, just thinking about it, is, you know, of a concern of over-regulation, over-governance, you know, creeping into our whole resource and reserve reporting systems, especially, you know, with ESG coming in. The question I have for you is, with SK 1300, do you think that's simplified to a certain extent our reporting, or do you think it's just become more onerous with additional regulations?
I think it depends where you're reporting, right? So, I mean, it becomes more difficult initially because you're trying to understand the regulation and you're trying to understand and make sure that you're compliant. I think that's like always key. It is more regulated, and I think Kathleen is on the call, so she could probably add to it. It is more regulated in terms of exactly what information they want. It's very similar to an NI 43-101 technical reports, but much less detailed. So it's not, you don't have to produce these reams of documents. And that's the first thing most companies did. They went and published technical report summaries and like massive amounts of volume and like almost over disclosure. And I think that's what we're trying to, as a community within the SK 1300 reporting, trying to understand what the SEC is looking for. So looking at how they respond to companies in terms of technical reports. And it's a difficult space. I think it's a space that's very fluid at the moment. And we're all trying to, I guess, you know, if you haven't received a letter, wait for your letter. They're going to find something, and then correct your process and go on. So it is, for us, it was more disclosure that was needed. It's also not a Crisco code, so there is the concern, and Ken mentioned this 2 weeks ago, is as the Crisco code starts developing and evolving in the next 5, 10, 15 years, and SK 1300 remains the same, then you're going to see a large divergence again. And then it's going to be difficult to maintain two codes. So currently, there's similarities, there's differences. As long as you understand what those are, that you're good to go as the years progress, unless SK 1300 then realigns itself. But they don't see themselves as a Crisco code, and they aren't a Crisco code.
Okay, thank you.
Thank you, Nicole. Darren, thank you very much for a very nice presentation. Well done. Just a very quick one, Darren. Yeah, you guys at AngloGold Ashanti, I must say, you guys are leading the industry in terms of, you know, using R-Cubed and how you are administrating your reporting. And just a question, do you believe that having R-Cubed in place and set up with AGA, did that make the reporting on SK 1300 a lot easier?
Yes and no. So no, because we did a lot of the background work. So Adrian's on the call. Adrian works with me, and we did the whole matching of the SAMREC and the SK 1300 requirements, and then we built it into the system. So what R-Cubed is now for us, we've helped them develop, right? Where it helps in terms of SK 1300 is because we've built it into a system. It's auditable. It's one source of the truth. We test, and systems go haywire at the best of times. We test and we make sure that whatever we've tested is what we're reporting, and we're constantly checking ourselves. But now that we've developed the process, it is easier. So it was painful 2.5, 3 years ago when we did it. Where it's going to be painful now is where we're progressing to a primary listing and how to understand that. It's not necessarily difficult. It just means we don't record SAMREC necessarily. But so it helps in terms of being auditable and single source of the truth, and you've got these workflows, and you really have a process-driven approach. But we had to develop that understanding from our perspective and try and match, and with the intent that we didn't want to duplicate work for our qualified persons.
Dr. Tanya Marshall has been actively and continuously involved in diamond and gemstone exploration in the mining industry since 1985. She's got a PhD from WITS, achieved in 1990. In 1996, Dr. Marshall founded Explorations Unlimited and has been involved in consulting and contracting to numerous South African and international exploration mining companies. She's also an honorary professor at the Department of Mining Engineering at the University of WITS. Dr. Marshall is a fellow with chartered status of the Geological Society, a member of the SIMM, a life member of the Geological Society of Africa, and registered with SACNAS. In addition, she's an active member of the SAMREC, SAMBEL, and SAM-ESG committees, and chairs the SAMREC Diamond Working Group, and is the immediate past president of the GSSA. So with that, thank you very much, Tanya.
Okay, so when we look at the evaluation of diamond and gemstone deposits, many things are very similar to most other mineral commodities, but there are some strange peculiarities that I want to highlight as we go through. Note also that in addition to the standard clauses in SAMREC, there's a diamond-specific section within the SAMREC code, but there is also an additional guideline document that needs to be complied with. And the reason being that diamonds are different. And two of these specific things that I want to highlight showing this difference is the low grades of diamond deposits, both for kimberlite pipes as well as alluvials. We're looking at parts per billions, and these are parts per billions for the very richest deposits. The other thing that complicates matters is the extreme heterogeneity, specifically of alluvial deposits. Some of the kimberlite deposits are also very heterogeneous as well. The other thing that complicates matters is the fact that you can't substitute quality for grade. Quality in diamond world means something completely different to grade. The most important difference has to do with the specialized field of diamond valuation. In terms of most other commodities, gold, platinum, whatever, for example, the price of gold is the price of gold is the price of gold. You go to the London Metal Exchange and you look up the price of gold and off you go. Not so with diamonds. The physical characteristics of diamonds are going to influence their value or price. Now, most of you will know the main ones, these different physical attributes, as the 4 C's. Cut, or the shape of the diamond, the carat, or its size, the color, and then the clarity, which refers to the number and nature of inclusions. Now, each of these different features has a significant impact on the value of either a parcel of stones or on individual stones. We look at the cut or the shape. Some shapes are more desirable from a diamond buyer's point of view, and so they're going to command a higher price than others, even though any of the other features might all be similar. With respect to clarity, obviously, if you've got a stone that's got more or larger inclusions, it's going to have a lower value than one which is clear. Colors. Because of their rarity, some colors are going to have a much higher value than others. And then we have a look at size. Bigger is generally better, but not always. But where there is an effective size, it can be quite significant. And I want to just highlight this particular section here, which shows that there is a strange relationship between the average diamond value and the underlying size. If, for example, we take a 1 carat stone, which here is, let's say, $10,000. A 2 carat stone will not be $20,000, but it can be significantly more. And by the time we get to 5 carats, we're not looking at 50,000, but in this case, close to 140,000. Now, putting a value either on a single diamond or on a parcel of stones is dependent on some combination of all of these features. And putting a value on diamonds is not something that a geologist, an engineer, a mine manager, or a CEO generally does. This needs to be done by an experienced specialist diamond buyer. Right, if we go on to look at figure 1, which we're all used to. In the diamond world, we use a diamond-specific figure 1, known as figure 3, where we will use a diamond resource or a reserve. If we're looking at other gemstones, it will be a ruby resource, an emerald reserve, or a gemstone exploration target. There's pretty much no difference between exploration results, reporting exploration results of diamonds than any other commodity. There are a few extra things that we would look at in diamond projects. What I've got here is a list of many of the things that we would include in our exploration results. And you can see there are a number of things which are diamond specific. But just as with any other exploration program, we wouldn't present it in a way that implies the discovery of potentially economic mineralization. We would put in the positive and the negative, the good, the ugly, and allow your reader to draw conclusions. Just like any other project, you can use historical data if the CP considers it to be relevant and reliable. We can also use data from adjacent or nearby properties. But very often this is where we run into issues. Looking at kimberlite deposits, kimberlites are discrete bodies, and they generally occur within clusters. Now, not every pipe in the cluster is going to have the same grade or diamond value. So you need to be aware in using information from adjacent properties, even if the other pipe is still in the same cluster. It's even more important when we look at alluvial deposits. This is a real-life example up in the DRC, where this is an old worked-out deposit, extremely high grades, good recoveries. Now, if your deposit is this one, The geological setting is similar, the bedrock conditions are similar, depositional environment is similar, so you could certainly use the information from here. Not so if this is your deposit. It's also wouldn't work out if this was the gravel on your property and you were comparing grades to the adjacent property, which had a gravel that looked like that. So it's in diamonds, it's probably even more important to be aware of taking information from adjacent or nearby properties, unless you can demonstrate relevance and prove reliability. Also looking at adjacent or nearby properties, we've also got to find some physical evidence. Now, simply because your property is along strike to one that has a dike, and in this case here, we're looking at a property in Lesotho, known kimberlite dike, which has been sampled, and in fact is currently being mined. And this here is your property. It would be very tempting to extrapolate everything along strike. Doesn't work. So there does need to be some physical evidence that anything from an adjacent property must run through yours. We've all also heard the adage that mineralization does not stop at a fence boundary. Well, sometimes it does, and particularly with alluvials. The red is a gravel run that was being mined, and that's the fence boundary. Competitor company went in and took up the property beneath, expecting that the run would continue. Well, it didn't, because a combination of a quartz vein and a change in geology created a pothole that the gravel disappeared into and didn't continue on surface on the adjacent property. Using exploration targets or using exploration results to identify exploration targets, there is no difference to any other minerals. You still identify conceptual or speculative targets based on desktop studies, which may or may not represent any discovered mineralization. You also can identify pre-resource mineralization, which either doesn't have RPEEE or has insufficient technical information to declare a resource. No difference whatsoever. Likewise, when talking about your exploration target, mustn't be misrepresented as a diamond resource or a diamond reserve. You still quote your estimates in terms of ranges. You're also not allowed to just state the included carats. For example, I've got a diamond deposit of 100 million tons. You need to identify not only the quality, quality and quantity, which in diamond case is volume and grade. You also need to include the diamond value, even at exploration target level. Reason being, if you have an example, take an example here of a diamond deposit, 150 to 200 million tons, grades of plus 2,000 carats, going to be very, very different situation if your diamonds look like this or if they look like that. So even at the very early stages, volume or tonnage, grade, and diamond value have to be included. And this is very different to many other commodities. When we talk about kimberlitic indicator minerals, it's most important to realize that these are not applicable to alluvial or marine deposits. But they can be very useful in primary deposits to provide indirect evidence for the potential occurrence of diamonds. And they're very useful to use in early stage ranking at exploration target level. They cannot be used to infer a grade or a value at resource level, and they also have limited application for project value. Right, so if we move on then to the resource, pretty much the same as for most others. Here we have the definition of what a diamond resource actually is. So if we look at it, the first thing that we need to identify is RPEEE. And again, there is no difference with any other commodity. You still have to demonstrate that it has RPEEE. You still need to look at geological and resource parameters, mining and process issues, various other things that are going to affect your RPEEE. And if you are looking at eventual, it's important to note that diamond deposits generally have a much shorter time frame than other commodities. We're talking generally 2 years or less. The next thing we want to have a look at is the geological model and the sampling type and spacing, drilling and sampling. In contrast to the coal resource estimation, we don't have any set drilling or sampling criteria. Your drill program must be optimized according to your geology. And again, you're going to have different parameters for different shapes and the number of geological domains and grade variation. I want to highlight this, that in complex deposits, it might be very difficult to ensure that the samples are representative, requiring increased sampling. Now, when we talk about complex deposits, alluvial deposits, kimberlite dikes, you can even have kimberlite pipes that have multiple facies in it, and that's going to increase the complexity of the deposit. So when you're looking at drilling and sampling a diamond deposit, you will often need more sampling than other commodities to get to the same level of resource classification. Looking again at sampling and the importance of taking samples. You need to take samples at resource level from the property or from the geological unit in question. So you can't base your resource grade or resource value on production data from elsewhere. For example, here, if you've got some detailed information on this kimberlite with its different facies, you couldn't use those same grade and value parameters for this kimberlite deposit because your facies are different and your facies are likely to have different diamond carrying capacities. You would also not be able to look at the historical information available here and apply it to these deposits. In the alluvial space, as you can see, this has been extensively worked out here. So obviously the recoveries were pretty good. You can't try and calculate or even use the known grade recoveries from here in your current river system, not at resource level. So with respect to resource level, you cannot estimate your volume based on geophysics or satellite images alone. So what we're saying is, here is a beautiful example of a river system. You can't just put an envelope around the whole thing and say, well, that is going to be my resource volume. It might be your exploration target volume, but not your resource volume. Here you need to have at least some corroborating drilling or pitting data. Now, Mario spoke with us earlier about realistic extrapolation around data points. And this is probably one of the important things here too, is to have realistic extrapolation around where our pits and our samples are. Whatever extrapolation distance you use, or whatever extrapolation method you use, we require that you justify that. You can't simply use a geophysical model. No matter how well done it is, we still need some corroborating drill data. And please, no spotted dogs. And finally, for each category, you need to disclose the basis of classification. Now, like most, or as with most all commodities, we use the same classification: the inferred, indicated, measured diamond resource, and the probable and proved diamond reserves. Now, just to note that we seldom report to measured resource or proved reserve status. It's not that you can't get there, but very often, because of the amount of drilling and the amount of sampling that you need to do, because of the heterogeneity of the deposit, it's just not done from a cost efficiency point of view. When you report your grades, you can do it according to volume, area, or mass. And area is something which is different to what most of you are doing, particularly when we look at the marine environment. The third dimension, the thickness of a marine unit, might be a few centimeters. And so the planar grades are easier to deal with. When we report our volume and tonnage, grade, and again, and quality or value at all levels of resource classification, the other thing that we need to include is the bottom cutoff size of the diamonds, because it does make a difference to your grade if you are recovering all diamonds greater than 1 millimeter or all diamonds greater than 5 millimeters. So it's fundamentally important that we get the bottom cutoff size in the tabulation or the resource statement. Again, as we've mentioned, you can't have included carats without the details of the quantity and the grade. And you also can't include exploration targets or historical estimates. No difference there. When we look at the statement here, that our category depends upon the increasing level of geoscientific knowledge and confidence. In diamonds, the applicable word there is confidence in the data. And confidence in our data refers to both how much bulk sampling we've got and also the uncertainty in demonstrating spatial continuity. As we saw earlier, diamond deposits can be extremely heterogeneous. And so this issue arises specifically when we look at low-grade or large stone deposits. Primarily alluvials, but many kimberlite pipes are also low-grade large stone deliverers. Best example is probably Letseng in Lesotho. Now, in the diamond space, there are often very inventive ways of estimating grade. Now, we're not in any way trying to limit estimation methodologies, But we are asking that if you use a methodology that is novel, untested, little understood, or non-standard, please give sufficient details for the reader to understand what you're doing, why, and then also demonstrate that it is a valid method and not a black box situation. Here are a number of models that might need some specific details when you talk about them. And I'm specifically going to mention geostatistics. While these are well-known and highly effective in kimberlites and also in marine deposits, they are not universally applicable to alluvial deposits. So if you do want to use them in an alluvial setting, please, you need to demonstrate applicability to that deposit type and justify your methodology. Another one I want to highlight is the use of the metal equivalence model. This is where you would report grades of multiple minerals in terms of the dominant mineral. Over the last couple of years, we're seeing quite a few polymineralic gemstone deposits coming to market. And we can also apply many of these same principles to heavy mineral sands. But if you use the metal equivalence model, be sure then you need to provide all the details that SAMREC requires in the metal equivalence section of the SAMREC code. Microdiamonds. Microdiamonds are not applicable to alluvial or marine deposits. They're only applicable to primary, typically kimberlite deposits. Now, the SAMREC code tells us that for a diamond resource classification, you need diamond grade as well as diamond value. Now, you can estimate diamond grade on microdiamonds. Estimating diamond value requires macrodiamonds. So if you only have microdiamonds, you cannot declare a resource. Resource requires both grade and value can only be determined on macrodiamonds. There are certain circumstances, if you've got a producing mine where you've got a resource, where you've got sufficient macrodiamonds to get a diamond value, you can extrapolate down into the pipe under certain circumstances where you can demonstrate geological continuity, where you've got a preliminary size frequency distribution, and I'll come back to that in a second, and if you give us some detail as to how that is done. Right, there is no such thing as an in situ macrodiamond grade. If you take a sample, whether it be kimberlite or gravel or whatever, and you put it through any one of these or each of these different diamond plants, a rotary pan plant, a DMS, or a bulk X-ray machine, you're going to get different grades. That's a given. The grades will be different. What you can't do is take any of those grades, multiply them by a fudge factor based on estimated process efficiency of that plant, and then back calculate an in situ grade. You don't get in situ grades. You only get processed grades. And the recovered grades are very dependent upon the process, the plant, how efficient it is. So when talking about diamond recoveries, we need to know something about the relative efficiency of the technology that you are using to estimate your grade. If you're basing your grade on microdiamond estimates, we also need to know the details of that. And again, the importance of bottom cutoff screen sizes. When you're referring to bottom cutoff, top cutoff, or any other size, please define the system that you are using. Let us know whether you're using the DTC or the square mesh, the tiler mesh. And this is a very useful thing to have, is a table in your document that shows the correlations or the conversions from one sizing system to another, particularly when it comes to looking at grade and value, because grade is generally determined using the DTC sieves, whereas value, your diamond buyer is typically going to give it to you in terms of grainer sizes. And for the uninitiated, it can be very confusing to talk about one size and another. So please do show us what you were using and the correlation between it. So when we do a resource estimate, we need to identify the different geological domains, and for each geological domain, we want to have some information regarding these various issues: area or volume, density, grade, size frequency distribution, diamond value, RPEEE. Keeping in mind that the majority of your inferred diamond resource should be upgradable to indicated diamond resource if you continue your exploration. And the importance of that can be shown here. So this is your exploration drilling, and you do some microdiamond analysis through your boreholes, and you say, well, this is my inferred resource. But when you do further work, you discover that only this little bit here is upgradable to an indicated resource because the grade here is payable. The rest of it falls away, and that is in conflict with this clause in the code. So if you do all of this information per individual geological domain, it is very easy at the early stages to throw out stuff that doesn't actually have RPEEE. And again, and I said this before, and I'll say it again, for every classification, every category of diamond resource, we want to know the volume or the mass, the grade, as well as the average diamond value. It's impossible to assay for diamonds. Statistical estimations of grade have not been universally successful. So typically the way in which sampling is done in diamond resource estimation is through bulk sampling. And here are some of the methods that you would use in a marine environment, as well as a land-based environment. And as you can see, when we talk about bulk samples, we actually mean bulk samples, not 25 kilos. Once we move from an inferred resource classification up to indicated, we need to have a much better understanding of the diamond grade, as well as the stone size distribution and the diamond assortment. And so you need to process significant material through your pilot plant. And again, showing some methods in which that is done. Just a note on semantics: bulk sampling, trial mining. In the diamond space, there's not much difference, except the scale. Generally, when we talk about bulk sampling, we talk about the process that goes all the way from exploration target up to indicated classification. And trial mining is the pre-feasibility study that would take that indicated resource and convert it to a probable reserve. And because many of the diamond recovery plants are modular, you can move seamlessly from a bulk sampling operation to a trial mining operation and to full-scale production. When it comes to putting a value on diamonds, we give some guidance on the number of carats that you require for evaluation to get into a particular diamond classification category. So if you want to classify something at an inferred resource level, we suggest that 500 carats should be the minimum number that you would be looking at. In terms of an indicated resource, depending upon the environment that you were in, you would need something between 1,000 and 2,500 carats. Now, this is a guidance number. It's a recommendation. If the competent person feels that there should be a different number, then they need to motivate for that. An example again is Letseng, where they mostly have stones that size and not much else. Even at 5,000 carats, getting an accurate indicated resource is under discussion. Okay, size frequency distribution. A size frequency distribution, an SFD, needs to be done at all levels of diamond resource classification. Now, an SFD looks at how the sizes of your diamonds are distributed throughout your deposit. And this is important because we go back then to the relationship between size and the value or price of the diamonds. If you look here on the y-axis, percent carats larger than Z. So here, let's take the easy one. At 50%, now 50% of your stones will be larger than the number down here. So for the brown line, 50% of our stones would be larger than 0.2 carats. Compare that with the green line, which is 50% of our stones would be greater than 0.1 carat. The implications are that the recoveries from this facies deposit would be larger than the stones from that deposit, which would make a big difference in terms of income and potential profit. But then we look up a little bit further to this area here. We look at stones greater than 2 carats. The green line now has 15% of the stones are larger than 2 carats, whereas on the brown line, only, let's say, 6% are larger than 2 carats. Showing that although this facies, pipe, deposit, or whatever has many smaller stones, it also has a large stone population. And as we mentioned earlier, the size of large stones increases the potential income. Looking at an SFD is vitally important at all levels of diamond classification. And as per guidance, we suggest that you have a minimum of 100 carats for a very low confidence SFD. When it comes to doing a valuation, it's important that it is on run of mine. Please don't select your 10 best stones and go and sell them and make that your average diamond value. You need to have the same bottom cutoff for your valuation as you have for your grade estimation. You cannot do a grade estimation based on your stones bigger than 1 millimeter and your valuation based on the stones greater than 5 millimeters. The bottom cutoff size must be the same. Valuation also needs to be less than 6 months old. Very good example was the COVID event. If you had taken an average, your diamond value here, or even here, 6 months later, it had fallen off a cliff. So when looking at diamond value, one does need to be aware of what's happening in the world or regionally that might affect your diamond price. We do allow certain circumstances where you can use an existing older valuation, where you can combine that with a size frequency distribution to infer or to model a current price. It's up to the competent person to show justification for that. Looking at a diamond reserve, no difference to any other deposit type. You look at the same modifying factors. That would be your resource, dike resource, and then you convert it using all these modifying factors to create the reserve. And we use the same contingencies and contents as SAMREC Table 1 and 2. So in summary, if we look at anything pre-resource, it cannot be included in a technical study and it cannot be converted to a reserve. An inferred diamond resource can be included in a scoping study, but cannot be converted to a reserve. An indicated diamond resource can be the subject of either a pre-feas or a feasibility study to convert to a probable diamond reserve. And technically, you can take a measured diamond resource, do a feasibility, and convert it to a proved diamond reserve. But remember, this is very seldom done in practice. Economic assessment, absolutely no different to any other commodity that you might be dealing with. When we look at SAMREC Table 1, we need to include everything from all of the sections 1 to 9, exactly as for any other commodity. Just to note, there is a section 10 that deals with specific reporting requirements for diamonds and gemstones that need to be included. It's not there to be included as a separate section. Please include all of this information in the relevant section above. That is me, so I will stop sharing, and if we have any questions, I'd be happy to take.
Thank you very much, Tanya. So there was one in the chat from Dion. It might be interesting to mention the types of QA/QC procedures during bulk sampling, i.e. when green irradiated diamonds or ceramics are used to test recovery at the bulk sample plant. These are very different to CRMs produced typically by AMS used in hard rock deposits.
Yes, again, the guideline doesn't tell you which testers you need to use. We need you to tell us what you're using and why you're using them. But the comment that you've made there, Dion, yes, they are not the same stuff as you use in hard rock deposits. Marcus, you have a question?
Hi, Tanya. Yeah, very interesting talk. I really enjoyed it. And it actually, like, I mean, I knew about the diamonds value that don't increase like linearly, but, you know, it never made me think up until your talk today that how would you, and perhaps you don't have an immediate answer for me, and that's fine, but I was thinking, you know, how do you actually estimate value if value doesn't increase linearly? Because our estimation or I mean, I think you mentioned like novel estimation methods, because the typical estimation methods is linear. So I was thinking, how do you actually estimate something that doesn't increase linearly? And also then when you mentioned, I think it was in slide 33, when you report an average value, how do you calculate an average from something that isn't linear? But anyways, very interesting talk. I really enjoyed it. Tanya, no, so I just wanted to thank you for the interesting talk. I really enjoyed it. And then I asked a question, but it's fine if you can't answer it right now, because it might be very technical. But I was thinking about, how do you estimate value with when the typical estimation methods are linear, but your value doesn't increase linearly, and how do you calculate like an average from something that isn't linear? But I find it very interesting. Thanks.
Typically, the value would be given by your diamond valuator, and they would divide your parcel up into different size fractions, and you would do almost the same as you do for a size frequency distribution. You would calculate a value frequency distribution, and that would give you indications as to which size fractions you had the most value from. And then depending upon what your market was and who you were selling to and what you were going to do with it, you would then decide what was going to be the target value that you would be looking at.
Okay,
Yeah, Matt?
so
sorry, carry on, Marius.
No, thanks, Tanya, for the answer. I was thinking, in terms of like the actual step of estimation, because you mentioned like the bulk samples that are taken, but I still assume, you still interpolate and extrapolate into the rest of your model, and that actual mathematical process, how that then, but perhaps, it's getting too technical for just a Q&A. So that's fine.
We'll take that one offline.
Yeah, no, sure. Thanks, Tanya.
Thanks, Marius. Yes, Matt?
Yeah, I've got 2 questions, if I may. First one is, are you seeing any impact of the synthetics on diamond valuation, and do you think that's going to continue, or what's your feeling on that side?
That is a very real issue, Matt. And at the last diamond conference that we had in Kimberley a couple of weeks ago, subject of extreme debate. Some people don't think that it's going to continue, that synthetics will always be almost a costume jewelry type level, whereas others have very real concerns that, specifically with millennials who are more concerned about getting money to buy houses and cars and to live, rather than have a big fancy diamond, that it might actually become a more serious problem down the line. At the moment, I think the jury is out, but we are watching this space very carefully.
Okay. The other comment or question that I have is on the use of geostatistics and the definition of, or ability to get to measured resources. I certainly, in my experience, have been very surprised on the upside of the applicability of geostats in kimberlitic, especially deposits with well-defined facies and the higher grade ones that I've worked on all parameters that I've looked at, including density. And so I don't think we should discourage practitioners from testing geostatistical methods to establish continuity, despite the sort of comments and the issues associated with sort of low concentrations in particulate nature. I think we should really, test all the methodologies that a resource estimator has at his disposal. Do you have further comments?
I think there's a bit of misunderstanding there. Geostats has worked very well in many cases, particularly marine deposits. They commercially successful in particularly alluvial deposits. And that is where I have a bit of a concern with people just applying things willy-nilly rather than thinking about what the application is. So by all means, use all estimation methodologies available, but at least think about the applicability of that to your specific deposit. As you mentioned, high-grade kimberlite deposits works very well. Low-grade, you have a bit of an issue. So if you're dealing with a low-grade deposit, just be aware of the issues that can arise in that particular kind of deposit.
Just a bio on Jeremy. Jeremy has held a number of geologically related positions with consultancies and mid and large tier mining companies during his 35-year career in the mining management. Okay. He's worked for mining companies in South Africa and gold and platinum group elements operations, PGE, and base metal exploration, and in the nickel copper mines at Sedibi Piqua in Botswana. Consulted in a wide range of commodities and deposits, largely through Africa, Saudi Arabia, India, and Kazakhstan, with occasional assignment in US, South America, and Europe. His key focus is on advising on best practices in mineral resource data collection, carrying out and guiding mineral resource estimation and mineral resource reporting in accordance with internationally accepted minerals reporting codes, such as SAMRAC, JORC, and NI 43101. Jeremy holds a BSc Honours in Mining Geology from the University of Leicester and an MSc Engineering from the University of Wits. He's a Fellow of the Geological Society, is registered as a professional natural scientist with SACNAS, and is a Fellow of the Professional Society of Independent Experts of the Subsurface Resources in Kazakhstan. Jeremy is currently Head of Mineral Resources at the MSA Group, where he established and has continued to grow MSA's International Mineral Resource Consulting Team. So with that, Jeremy, I'll hand over to you. Thank you.
Oh, great. Thank you very much for the introduction, Nicole. All right, so I think a bit of background. You know, people might ask why the title of this talk, and why the question mark at the end. Now, I called my talk "Density, the Neglected Variable?" ? And the reason I've got a question mark is I asked myself the question: is it still the neglected variable it was, or have things improved along the way? Anyway, we'll maybe ask you to think about that yourselves through the course of the presentation. So, like many geologists who started their career on the Wits gold mines, density was never really a point of discussion. Mineral resource management was in the realms of the survey department, and geologists were largely focused on structural plan, sedimentology, and trying to convince the miners to stay on reef without leaving too much behind. Besides, it was all quartzite or silicious conglomerate, and 2.71 seemed to be a reasonable number, and it was never really questioned that much. As our careers moved on and the industry's changed, we moved through the platinum sector and some of us into base metal mines, some into different types of gold deposits further afield. And mineral resources became more under the geology mandate. And clearly the need to understand and estimate density became more important, more of a talking point. So as I said, is it still receiving the attention it deserves, or is it still the neglected variable? Right. So, density, you said feeling a little bit left out at the moment. I think we should always remember, and I know one of the previous speakers, Marius, brought this point up, content, which is after all the mineral resource, is a function of volume times density times grade. And one would assume they should have equal importance. But it doesn't seem to be that way still. One looks at volume, we have very advanced geological modeling software, Leapfrog, etc. Geologists spend huge amounts of their time modeling these deposits from their drill hole data, etc. in great detail. Density There's rarely enough QA/QC, if any. Far less attention is paid to the estimate. Sometimes collecting density measurements is left to the end of the program. Poor practices like subsamples are still used, and density is often determined on just a selection of the samples, which in some cases might be appropriate. Grade gets all the attention. Fantastic refined geostatistical techniques, the assaying, QA/QC, huge amounts of QA/QC, laboratory selection procedures, check assays at different labs. It never gets enough. But poor old density gets the short end of the stick. But don't worry, there's a bunch of people who have been harping on about density for some time. And I actually was going to give a talk similar to this a few years ago, but Ken kind of beat me to it in his 2021 paper entitled Density Bulk In Situ, or SG, published in the Journal of South African Institute of Mining Metallurgy. And many of the points that Ken Lomberg made, you will see these points again today, and many of us share the same view. But essentially, Ken Lomberg stressed that density must be seen as a variable with the same status as grade, given its use in estimating tonnage and contained metal. I just listed these three references here because they're very, very useful. Ken Lomberg's paper, which you can get straight off the internet. The Australian Institute of Mining Metallurgy Guide to Good Practice has got a very good paper in by Lipton. And of course, CIM Mirror Exploration Best Practices Guidelines has quite a lot of commentary on density. So if you need to catch up a little bit, that's not a bad place to start. Right, terminology. You know, we hear this SG, relative density, in situ bulk density, dry bulk density, lots of terminology. But basically, just to set the matter straight, specific gravity is the same as relative density, and it's nothing more than the mass of the material to the mass of an equal volume of water, or other substrate in which is measured, by the way. But we use 4 degrees C, because conveniently then, water has the same as an SG of 1. So SG basically is a ratio and doesn't have a unit. Density, of course, is the mass of material per unit volume. And if you're doing SG or water displacement methods, it's very easy. You just times the answer by 1, or essentially just put a unit at the end, and then lo and behold, you've got density. People often said to me, what about when the water temperature changes? What difference does it make? Does it make any difference if you're on the high veld or you're at the coast? So the answer is pretty much no. And as an example, density of water at 37.8 degrees C, which would be at a pretty hot place, is 0.99318. So the error due to that not being 4 degrees C is 0.7%. And in most situations, it's about 0.2%. So we really don't have to worry too much about it. And practically, we measure SG and we call it density. But there's more on that later on, because I know people are itching to talk about pyknometers. Anyway, the next one, in situ bulk density, is density inclusive of voids and porosity and moisture. But of course, the one we're really interested in is dry bulk density, or in situ dry bulk density, which is the density of the dried material. Now, I have to say, the coal guys will disagree with me. They use moist density, and I think a few other people do as well, but I don't really do much with coal, so don't know too much about that. But basically, dry bulk density is what we're aiming. But you'll see in this talk, I'll kind of move between density and SG a bit, but don't kill me for it, right? It's not that, doesn't matter that much. Okay, so there's actually loads of ways of determining density. And I'm really not going to talk about bulk samples too much, or if at all. I'm more interested in these small little samples that we use as an input to mineral resources and, you know, estimating our block models and report our mineral resource, etc. But bulk samples is another. another thing involving big weightometers and the like, so I'm not going to talk about. Okay, so here's one. This is a hydrometer. It measures the SG of liquids, but unfortunately has no application mineral resources. But anybody who's done any brewing might know that it has other applications. And I'll leave that one there. There's a thing called simple pycnometry. Essentially, you just displace water. And people often forget this method exists, mostly because it's not that accurate. But essentially, you weigh the object, determine the water by chucking it in a beaker that's graduated. Therefore, density is weight divided by volume. There's some other methods that people use where they overflow the water from the beaker and they weigh it and they do all sorts of stuff. But we generally don't do anything with this because it's quite time consuming and it's not accurate. And obviously it doesn't take porosity into account. But just be aware that, you know, there are very simple ways of doing things, right? There's a variation on the theme, the pycnometer bottle. It's a displacement method, often used for density of liquids, but you can use it for soils and solids. A little bit impractical again. So we don't really find any application in mineral resources for such a vessel. So this is one that most of us rely upon quite heavily. It's a gas pycnometer. If you send your samples to a laboratory for density testing, it's quite likely that this kind of system will be used. Often people refer to this directly as SG. But essentially it's a gas displacement principle. I vaguely remember Boyle's law from when I was doing physics at school, but it's something to do with pressure changes displacing gas by a solid object. It's a very accurate instrument, but its limitations are that it works on bulk samples and doesn't take porosity account, but it's widely used in the industry today and commonly used for non-porous core samples. Now, if you send your sample to the lab for density, please find out exactly what density they're doing, because there's a whole bunch of ways in which they can measure density. This is just one of them. Generally, people refer to this as SG. Now, of course, the one we know and love is Archimedes' principle or water immersion method. So this Archimedes, I've got quite a lot of respect for this guy because he was around 287 to 212 BCE. So that's a couple of thousand years ago, and he worked out a whole load of stuff. But one of which was the principle that when you immerse something in water, it's acted upon by an upward force, which conveniently enough is equal to the weight of the water displaced by the object which is immersed in the water. So therefore, it's very easy for us to have this simple calculation of weight in air divided by the difference between the weight in air and weight in water, i.e. the mass that's displaced. That's SG, or density. So SG becomes density when you add the unit to it, essentially, assuming the water has a density of 1. But very important for us, you know, there's this porosity issue that we need to deal with as geologists. And it's also very important these samples are dry, because we're looking for dry density, remember. Okay, so don't dip it in water and then pull it out and then weigh it in air, right? It won't be dry anymore. It'll be a problem. Seen that done a few times. Okay. So a lot of people know this type of scale. It's readily available commercially. People call it a density scale. It's like a fairly accurate snow-wreck scale with a cradle underneath that lowers the sample into water. It's really commonly used in the PGE industry. My biggest issue with it is the size limitations. And because of that, it's become an excuse for people to take little subsamples for density rather than the whole length that is sent to the lab. But you know, the platinum guys like it because the guys in Merensky and usually too, they take such small samples, 10, 20 centimeters long. It works really well. But in terms of the size limitations, it can actually easily be overcome by weighing in increments. So it's not an excuse actually that the scale is too small. You can just divide your sample into 3 and do it 3 times and have the weights together. Get a full sample. Anyway, most people are aware of this one. And then we have the base metal guys. They like big samples. That little scale isn't going to work well for them because there's often a relationship between the density and the grade. So they need to know the density of the sample on which the grade is measured. Okay, i.e. the sample that goes to the lab. So we use the same principle. And there's all sorts of different contraptions you see around the world where people are trying to weigh big samples. The one on the left is pretty nice. That's a project up in DRC, where they've got a very specific thing they constructed, which works perfectly. They just use a little load cell that they suspend. The one on the right is in Central Asia. It's not really a method I would use. There's all sorts of things that can go wrong with that little band of material holding that piece of core absorbing water, and I don't know what's happening there. And every time he wiggles his hand, the weight changes anyway. So probably not the most recommended one on the right, but the one on the left is going to work pretty well. So guys, when you've got these big buckets of water, keep it clean, hey? Because obviously, if you have lots of suspended sediments, the density of the water will change. Your reading will be different. Okay. We talk about porosity and adjusting for porosity. Generally speaking, we coat these in wax. You know, I've heard lots of people talking about cling film, and I even tried it once, and the sample ended up floating in the water. And to this date, I've never seen anybody demonstrate it to me successfully without trapping oodles of air in the cling wrap. So I think let's just get the wax, you know. So it's a pretty simple thing. You've got a little pot there with a gas burner under it. Obviously, have your fire extinguisher at hand and all your safety precautions that you need to take. But you basically just melt the wax, weigh the sample, dip it in wax, weigh it again, then do the water displacement. It's just a very simple mathematical correction, and that works pretty well. I've heard people talk about saying, well, let's just submerge a thing in water and see how much the weight changes when you weigh it out of water again, and then do an adjustment for the porosity based on the water absorbed. I think it can work in certain situations, but obviously if you've got a lot of channeling going on, the water will just fall straight out as soon as you take it out. So maybe certain situations it might work. There's a whole bunch of variations of what to do with water displacement methods, and I will refer you again to the paper by Lipton in the Australian Institute of Mining Metallurgy Good Practice. It is excellent. He describes 8 or 10 different versions of what to do with water displacement. So another one, there's the caliper method. Basically, this works on understanding the volume of the core and the weight of the core. So it's simple. You take a bunch of caliper measurements along the core, work out the average diameter and times it by the length and get the volume. Then weigh the sample, and then weight divided by volume is the density, right? So there's not much point in doing that most of the time because your water displacement or your water immersion methods are just so much more accurate. But when you've got things like this saprolite, this is from a gold project in West Africa. Saprolite disintegrates very quickly on drying. And remember, we want the dry density. So it's a bit of a problem. So the best thing to do is this caliper method. And basically, you need to grab this thing straight out of the hole. Make sure you've got accurately determine the volume of the length, maybe a nice 50 centimeter length. You cut the ends at right angles, and then weigh it. And then you go dry it. By that stage, it's all disintegrated, but that's okay. Then weigh it again, and then you can obviously get your dry density. It's pretty easy. I've seen people with saprolite trying to soak it in water, and it's just all sorts of bad things happen. But you know, that's probably the only time I would look at a caliper method. There's the assumed volume method. So we drill a sample. We know the volume of the core barrel or the rod, whatever it's coming up in. Therefore, the weight coming out divided by the volume of the core barrel should be the density, right? But of course, it doesn't take into account losses, particularly RC, these huge dust losses you get. Core diameter differences, you know, all drilling isn't equal. We've all seen core diameters change for strange reasons by drillers. But, you know, in RC, it's quite useful as a check to see what's going on. But because you've always got losses, you'll always have a minimum density using this. But in tailings, it can be quite useful in these cased augers. I'll talk about that in a little while. Onto tailings. So, you know, in South Africa, there's a lot of tailings reclamation going on, and obviously we have to estimate the mineral resources, so we need the density. So a couple of methods I've seen in use. There's the in situ volume, which is basically digging a hole, weighing what came out of the hole, drying it and weighing it again, and then determining the volume of the hole. So people can line it and fill it with water. I've heard people talking about using sand, although I've never done that one myself. But it's a very simple and obvious technique. Obviously, it's got some limitations because it's limited to the top of the tailings, and it's quite intricate and quite time consuming, and it's not something people are going to do a lot of. And just a comment there, as with all sampling, the bigger the better. So do some pretty big holes if you can. Your error will decrease. But often the tailings, this I called it the ice cream tub method because when I first advised somebody, they said, "What should I do?" And I said, "Get a tub of ice cream." And obviously, you have to eat it first, and then you know the volume of this ice cream tub because you can fill it with water and measure it, no problem. But essentially, you fill from the auger, you fill the tub up with tailings. You weigh it, you let it dry, you weigh it again. You know your moisture, you know your density. Pretty simple. Okay. But of course, everybody talks about compaction. Yeah, source of error. It's really tough when you've got really wet samples at the bottom of a tailings dam or in a wet area. And of course, there's lots of handling involved here where things can go wrong. Anyway. The geophysicists amongst us will say, no worries, we can use gamma gamma. And it is used a lot, the downhole probe. And it's pretty much exclusively used for oil and gas. And I think coal people use it quite a bit as well. It is a geophysical tool, requires some calibration. Whenever I've looked at it, I want to check it with some densities measured in another way, and I'll discuss that later. Because it's notorious for having interference issues in any metalliferous environment. So there's a lot of calibration challenges to deal with. And also remember, it's not giving you the density of your sample, it's giving you the density of an area around the hole. So it's not giving you exactly what you want. It does require a moisture correction. And one of the things that worries people is you're putting a radioactive source down the hole, and sometimes they get stuck, and people are worried about issues with this, as well as transporting them between different countries. Right. So that's all the kind of methods we've got around. There's probably a whole bunch more, but they're the ones that I'm most aware of. So now the elephant in the room, I think, is QA/QC for density. A lot of people don't do it at all. Some people do rather a lot, but it's rare. Generally speaking, it's quite neglected. And here my question is, does it actually get enough attention? And of course, similarly to assays, density measurements are subject to similar errors to assays. And it is quite important that accuracy and precision are understood with your density. And Lomberg also mentioned that in his paper, and also suggested that some more checks are done on moisture as well, because obviously, unless this thing is dry, it's not going to give you exactly the right answer. So let's have a quick look at this. All right, so here's my recommendations for minimum QA/QC for density. So water displacement, obviously, you need to calibrate your scale before, during, and after. So how often, I suppose, depends on how often you want to find it wrong and redo everything you've just done. Anyway, I think that density should have duplicates. So you should be selecting duplicates that you are doing perhaps the next day, because remember, if you do a duplicate measurement, you have to make sure you've gone and dried it. Huh? So you can't just do one after the other, because your samples now absorb some water. So you need to do your duplicates. Alternative methods are really important, very similar to the so-called umpire laboratory. Okay, many labs do both water immersion as well as gas pycnometer if you choose to spend the money on the lab. And I always recommend that you would use a standard, just the same as you would do calibrating any type of equipment. So in this picture here, they've actually got these three standards. They're non-porous materials of known density. And they basically, this particular company, every so often, it would measure these standards and make sure that the result was what they expected. It's quite good practice. In terms of SG, or the pycnometer measurements, yes, we also need to have pulp duplicates. Fortunately, most people are doing pulp duplicates as part of their assay QA/QC. So make sure that they have SG measurements as well. Again, alternative method. Strongly recommend water displacement if you're ever using a pycnometer on an assumption of no porosity. And one thing that people often don't notice is a lot of these standards like you get from AMIS or the like, they've got certified values for density. So you can do your control charts for density exactly the same as you do for, you know, any of those analytes that you're interested in. Okay, so somebody asked me once about, what about a blank sample for density? And I was a little bit stunned. Yeah, wasn't quite sure how to answer that one. I think it must be air, right? Zeroing the scale is probably the blank sample equivalent. All right, so it's really important when you get your density measurements as part of your QA/QC process to check them. Again, mentioned earlier by Marius, he's amazed what kind of numbers that you get in these density databases. A lot of these rocks are floating on water according to the densities, and some of them weigh more than solid gold. But anyway, it's human error. Everybody makes mistakes. But we need to check these things. When you get your density values in, just the same as you do with your grades, check for your values that don't look right. Okay. Here on this particular chart, this is a high-grade polymetallic deposit. Because there's two types of mineralization, you've got two very distinct populations. But it being density, fairly low variance attribute, you pretty much know what the ranges should be. Here there's a bunch of stuff. Not many, but they're there. 0.75s, 1.25s, 1.5s in that kind of bin. And likewise, there's some extremely heavy stuff that just cannot be in this particular geological environment. So, please check your densities, get rid of these out of range values or check them. Maybe something else is going wrong in the process. For the resource estimation people, don't put a top cap on them. If they're wrong, you need to just get rid of them, just cut them off. This kind of thing is a subject of much discussion. Pyknometer versus water immersion. And I've looked at this for countless companies, particularly in the South African and Zimbabwe platinum industry and elsewhere. The assumption with people mining igneous rocks is there's no porosity. This is a questionable assumption, especially when you've got zones of alteration, fracturing, etc. But this is an example, and I've got quite a few of these that give a very similar trend, where there's a very clear bias between your gas pyknometer and your field water immersion samples, your weight in air, weight in water. So in this particular case, it's a 2% bias towards the pyknometer. And I've picked this up a lot. Jarman did an MSc through University of Pretoria and quoted differences in the order of 5% in bushveld PG deposits. Okay, but again, when you do your analysis, get rid of all the outliers. They're not of any use. These are in pink on this one. A nice little technique used there was 3 standard deviations for the mean absolute average relative difference. Okay, but it's just noise, you chuck them away. Yeah, but so the question one has to ask, if you're a platinum miner, which is the density that you wish to accept into your mineral resource statement? And are you under or overstating your ounces? 2 to 3% is a lot of platinum in a platinum mine. I talked about probes earlier. Here's an example of when things don't work according to the plan. This particular client did a lot of downhole probes with no control to it. And then we had a look at this, and the client also then did his checks, and unfortunately it found that the probe wasn't really giving the same answer that the water immersion was giving. And this particular case, there was actually a 5% difference. So that's a lot of metal in a mineral resource, 5% just due to one factor. Okay. Tailings, I mentioned this earlier. There's a couple of methods in play. I'm not going to talk about the known volume digging the hole one because it's just a single point. But this is an interesting one from a tailings dam somewhere in South Africa, where they've done the right thing. They've looked at the auger diameter, the length of the rod, and the weight of the tailings coming out. But they've also done a known volume method with the container, a good old ice cream tub method. And you can actually see they give quite different results on a point for point basis. But if you look on the left, that QQ plot is crossing over smack on the mean value. So overall, the result was exactly the same, to the nearest 0.01, I think. So that was pretty good. But the one thing that does worry me about the auger diameter is we did get some unusual densities for this tailings dam. You can see on the right that value of 2. A lot of those auger diameter or the volume method was giving very high values that you wouldn't expect in this particular tailings dam, whereas there's only 1 or 2 with the container method. Hey, the time here. So I'm just quickly going to go about density applied and estimation. I don't want to harp on too much about it because there's too many ways. So first of all, guys, always composite grade by density. If you have any relationship whatsoever or any variable density in your drill hole intercept, some of these deposits are quite sensitive. This is an example of UG2 with dense chromatite with a lighter, a less dense middling, and just showing that the difference in the grade was actually 3%. If you didn't weight that one by density, you'd have a 3% difference in your grade. So if the platinum industry guys didn't weigh every sample, they would actually likely end up with a much lower amount of PGEs than is actually in space in the ground. Particularly these UG2 guys that have got these middlings. So another subject that's a bit more controversial, and I've had quite a lot of discussions with people with this over the years, is what do you do about density and grade relationships when you're interpolating? So this was mentioned by several people. Dadson, Danny Cricker in his 1981 quite well-known paper talks about weighting grade by density, and Lipton in the monograph, Alzheimer monograph, also mentions it. And I think we should remember that when we're estimating, we're actually estimating metal. Grade is just a convenience and is entirely reliant on the assumption of equal support. So an equal length is not necessarily equal support, right? It should be equal mass. So always remember that assays are proportioned by dry mass and not. Your assay comes back from the lab, not as grams per centimeter cubed. It comes back as grams per ton. And just out of interest, I did just a most simple calculation here, where one high grade sample has a density of 5 and a low grade has a density of 1, 2 separate intersections. Obviously, if you're going to creek this thing or interpolate this thing without weighting by density, you'll end up pretty much on the mean, depending on where your block is, which is 5.5. But if you interpolated the metal or the metal equivalent units, you actually end up with a grade of 6.63. Now that's quite a huge amount of metal difference, and I know it's a fairly extreme case, but one should always bear this in mind, and that density and grade relationships need to be quite well understood when you're doing estimation. Here's an example of a case where you need to weight by density. This is Basia Tin Mine. It's in Eastern DRC, but it's one of the highest grade tin mines in the world. In fact, you can see here just the model itself, not the mineral resource at any cutoff grade. It's just the model was 4% tin, 4.08. That's if I estimated it without weighting by density, but when I density weighted it, I ended up with 7.4% difference and got 4.38. That's a huge amount of cassiterite. The issue with cassiterite is it has a density of 7 grams per centimeter cubed, and it can contain up to nearly 79% tin. And if you look at this example on the right, this pale stuff is actually cassiterite, believe it or not. It's a type of pink wood tin, they call it, you get in this area. And you can imagine if you didn't do your densities correctly, if you just took these small spot samples, how wrong you could be. In the same sample length there, you could have material of 7, you could have material of 2. But yeah, it's an extreme example. So application of density in mineral resources, I started putting together loads of slides for this, but at the end of the day, there's just too many permutations. But essentially, that we vary from applying domain averages, where the transitional fresh averages is quite common, particularly when you don't have a lot of data or where your data are not very variable. The same with lithological domains, just apply for lithology. It's not ideal, but often people have collected a couple of hundred density readings and there's not much you can do with those with interpolation. So if you are interpolating, inverse distance is very common. Some people Krieg it. Probably not that necessary given its low variance, low CV. In any interpolation with density, just be very careful with sparse data density relative to your grade. Can be an issue, particularly if there's any relationships. One thing we do quite a lot is we interpolate assigned values based on rock type. So you basically look at all the rock types the geologists have logged and you apply a density to each sample based on its rock type, and then you interpolate that density. That works quite nicely, particularly in situations where the lithology is so complex that you can't model it as volumes using something like Leapfrog. Also, indicators have worked pretty well for some situations. Regression is a very nice way of applying density. Again, if you don't have enough data, and it's very simple, you just work out your regression formula. There might be several, and you apply it to your block model grade estimate. And in all these situations where you're composite and weighting by density, remember that every sample that has a grade needs a density as well. Otherwise, it's not going to work so well. Here's a few examples. Here's a tailings one. There we estimated using inverse distance squared. It works okay with these tailings. But we had 2 sets of data. One was the top one, sorry, the label's not there, but the top one is the ice cream tub, or the known volume, and the bottom one is the known volume of the drill sample coming out of the hole. And I think very quickly you can notice that the top one has much lower variability than the bottom one, and the bottom one even has some densities that don't really look like what you would expect. So in this particular case, we tend to favor the method where every sample has been packed in a container and weighed and dried and weighed again. Okay. Otherwise, both of them have the right pattern where you expect high and low. It's just that the variability and the weight of the sample coming out of the hole is quite high. This is one example where we did an inverse distance block model on the bushveld somewhere, some Merensky Reef. And it's just to illustrate really that the density does change quite a lot, you know, particularly in Merensky when you've got different slight lithological changes, different amounts of olivine, plagioclase, whatever these minerals are that's driving the rock density. So, and although they're over quite big areas, you can see each one of those bars is it's about 250 meters or something like that, 300 meters. They're there and they're important because are you going to mine at 3.1 or are you going to mine at 3? Again, you've got 3-4% differences here that you might need to deal with, and all these errors they add up along the way. This is quite a nice one. The one on the left is they're both regressions. They used bin data to get rid of the scatter, to decluster. But the one on the left is a very high grade zinc deposit in DRC, big zinc, where you have zinc, copper, and lead. And by combining all those elements together, we managed to fit some second order polynomial curve in. And we assigned the density to the blocks. And it seems to be a fairly reasonable fit. The one on the right is good old tin project, Basia. And this is just a straight regression between grade and the density. And you'll notice it has a bit of a curve to it. And that's quite easily explained because it shouldn't actually be a straight line. As for the mathematicians amongst us, you need to understand that they're both a function of mass. So there will be a curve to it, and you can play around with some calculations if you wish. Lipton's got an example calculation in his paper. But yeah, sometimes it can work well, but even you see on the right, there's some very strange data points there that don't seem to fit in with anything. So generally speaking, if you can, every sample has a density, much better way of working. It rarely is the case. Right, so that's kind of all my lecturing bit about density and what I think we should be doing in terms of QA/QC and measurements and using it. So I think, Nicole, have I got time?
Yeah, Jeremy, we're a bit over, but carry on.
All right, is people still awake? I wonder. Anyway, but this will only take 10 minutes, so bear with me, guys. This is a case study about a slightly unusual situation about how to understand density in a Gossan. This is a project in Saudi Arabia that the company Golden Minerals company is exploring, and they're in a quite advanced feasibility stage now about mining this VMS. There's actually two of them, Hawiyah and Al Ghadir, right next to each other. Okay, so this is a long section of Hawiyah, volcanogenic massive sulfide deposit. It has a total indicated and inferred mineral resource of 29 million tons. But what they're really interested in for the first phase of mining is the oxide mineralization in the Gossan. And the reason they're targeting that is it has quite an elevated gold content. In fact, the zinc and the copper are worthless in the Gossan. They're not going to extract them. They're mostly leached out or in some complex form that's not that easy to extract. But in the Gossan, there's 1.2 million tons at 2.1 grams per ton gold and 7.6 grams per ton silver. And that is the startup phase of their open pit. And then obviously, then they'll move into the massive sulfide. So the challenge here was obtaining some form of robust value for these oxides. This is a beautiful picture of the outcrop of the Hawiyah Gossan. And if you talk about geological continuity, you can pretty much see how continuous these these VMSs can be. It comes and goes where there's some wadis and things like that, but generally speaking, you can see this thing running along for hundreds and hundreds of meters. I think it actually extends for several kilometers in total. This thing is steeply dipping, but as you can see, it's a gossan. It's a bit, it's been beaten up by the weather a bit. It's got some holes in it, and it's a very variable composition. I'm not going to really talk too much about this, but essentially gossans are an alteration product of massive sulfides. And in this particular case, through various mechanisms, gold is being concentrated in the gossan itself, and then there's some supergene zone in around the redox boundary. Yeah, and I think the thing to notice here is if you look at the little cartoon of the gossan itself, this area here, there's quite a variety of rock types that have been identified. Those with saccharoidal silica, gossanous, argillaceous, chert. There's several types of gossan as well with different textures: spongy gossan, solid gossan, banded iron formation. It's all there. It's a bit messy. In terms of small scale geological continuity. So this is Algodea. It's another deposit close to Hawea that's going to also form part of the same project. And basically, you can just see that this altered massive sulfide at the top. It's in the sulfide zone, but it's obviously had some other later hydrothermal impacts on it. And then there's a slightly less impressive ridge to Hawea, and then some of this copper finds its way back up again, and here you've got on the edge of the gossan some chrysocolla and a bit of malachite hiding there as well. But essentially, this gossan is about 30 meters deep. Right. So earlier on, my clients, they diamond drilled this project, and of course they really battled in this gossan. It's made up of terribly friable, porous, hard and soft material. 1 minute you're in chert, next minute you're in just spongy, soft gossan. It's not possible to get anything decent out of this whatsoever for density, let alone assaying. You know, it's a real challenge. You have to be very, very careful when you're dealing with samples of such poor quality. This is an extreme example, I'll have to say. It's not all that bad. It's just to illustrate the potential problem. They did give up on the diamond drilling for assay work and went in with some RC, but it doesn't always give reliable information when you're trying to use it for density. And obviously the outcrop itself, you could see in those photos before, it's heavily impacted by erosion. And in this part of the world, wind erosion is quite an issue, and it makes little holes all over the place as the wind is driving the sand into these outcrops. So golden minerals, these guys are quite a quite innovative bunch, and they looked at different solutions. They had some consultants helping them, and there was different estimates of cavities. They varied from 10% to 30%. They didn't like the 30% one very much because it likely would have collapsed under its own weight. But anyway, but there was quite a wide range of cavity estimates, and obviously the amount of cavities are really quite important for the in situ bulk density of this gossan. So eventually the team says, well, let's just get some machinery in and open this thing up. And they did these mega trenches up to 8 meters deep and 5 meters wide. And they look like this. They look like little open pit box cuts, you know. But they did a number of these, and if you look at the photo on the right, under or very close to all these trenches, they have some RC holes just to understand the difference in grade between any samples they did in trenches and anything they did underneath. So they're quite good with figuring things out. Just here's some different pictures of the gossan and the sidewall. This one on the left is quite a nice solid ironstone with a whole variety of things going on. On the right, some argillaceous material, etc. You can see there's quite a lot of variety, and there's a bit of overburden chucked on top of it as well. And here, this one on the left, you know, a lot of this gossan is pretty solid, hey? I mean, you pick it up and it's not light. You know, some of this is ironstone, some of it is chert. It can be fairly bulky stuff, but of course it does have these cavities in it that we need to work around. So what they did there is they excavated these trenches, and then they went and built up a whole library. This is just a small example of their library of different gossan samples. And then we worked out an average density for each lithology that you're getting in the trenches. It was all done with water immersion and wax coated. It was checked by caliper method. Obviously, these are near cubes, so you can use your caliper and calculate what the volume is as well to get the density. But we settled on different densities for different rock types. And then the guys went in and they completed quite detailed mapping of these trench sidewalls, and particularly the gossan, sampled them. And then what we did with the mapping is we worked out the areas or the linear portion, and then we assigned density to it. We all got around the table and said what is a good void percentage for each one of these gossans, and we spent hours and hours and hours in these various trenches trying to calculate and come to a consensus on what we think the voids would be. And then from that point on, obviously, it's just a fairly simple piece of arithmetic to come at a density for each trench. So this one, we got 2.37 after 9% voids. This one, we got 2.45, less voids in this one. And this one here, we got 2.29 because there's quite a big void here that's full of sand. We don't know how deep some of these voids will go, but we thought we would be a little bit conservative. Sorry, 2.05, this trench. And these three mega trenches, we ended up on an average density of 2.29. Okay, and that is what we applied to the mineral resource because we didn't really have enough data to spatially estimate it. But essentially, one thing we found was the mega trenches had less cavities than originally proposed. Once you get away from that erosional area, this thing becomes quite solid. We ended up with 8% cavities in the end. The few core readings they did was 2.73, but obviously it's going to be a very biased density because a lot of the soft stuff and the lighter stuff has been washed away. And they had some issues with these RC weights, so we couldn't work with those at all as well. Then the project next door, Algodea, we did a very similar exercise. And we arrived at a density of 2.15. And just out of interest, we compared it with the RC weights that were done correctly. And we got a very similar density, which was surprising because I think the RC weights, if anything, would be an underestimate. You know, this is the weight of the material coming out of the whole group sample. There's no diamond drilling data in the oxide at Algodea. They learned not to bother from Hawaii. So overall, we thought it was a pretty successful program. And we will carry on doing some more work in the future and see how that 2.29 works out. So I'd like to thank the Golden Minerals team for permission to present this case study and acknowledge them for their innovative approach towards obtaining what I believe is a fairly robust density value for this gossamer material. And that is the end, and thank you very much for your patience. I did go over a little bit.
Thanks, Jeremy.
Okay.
If there's any questions, I see Sophie has your hand. Go ahead, Sophie.
Hi, thank you, Jeremy, for the presentation. It was quite informative, especially considering how density is, like you said, is being left behind when if all the other variables have been QAQC properly and all that. My question is on the, you mentioned the auger drilling casing versus the container method of determining the density. Yes, the first question I want to ask is, with tailings, you know that there's a material that is disturbed on top of the TSF due to the driving over and all that. How many meters should you remove this disturbed material before you can start either doing the ice cream method or the auger drilling? That's the first question.
Okay, so the ice cream method isn't done from the surface, it's done on material from the augers.
From the auger?
It goes all the way through the hole, every sample.
Okay, so let me, okay,
in terms of what's disturbed on surface, I actually can't answer that question because, you know, one should obviously remove the top meter or so, but in terms of compaction from driving around, I really wouldn't know the answer. Because not just compaction, it's movement by wind as well. You know, you pick up this tailings near surface, it's often more unconsolidated than elsewhere. It's very light, you know. So I think you get a lot of material removal by wind processes.
Okay. All right. So when you said with the ice cream method, you take material from the auger casing. Is this the auger with the spiral or just the casing without the spiral?
Spiral.
With the
doesn't
spiral.
matter. You can use the spiral for that one. It doesn't matter. For that method. Yeah.
I'm gonna need more information on this. Is it possible that we can talk offline?
We can talk, yeah. You know, there's a whole bunch of ways of looking at density and tailings, and you know, the acid test often is the metallurgists have got a good idea what they put on the tailings dam in terms of tonnage. So that's also a good number to look at to see if you're reasonably close. You know, I know there's lots of things that happen along the way in the tailings, etc. But the actual records of what was deposited on the dam can often be a fairly good indication of what you should be coming up with in the end. Yeah. So with tailings, it's just to look at lots of different methods and decide which one is working in the particular situation. Yeah.
Okay. Now I really need to speak to you after this.
Okay.
Thanks, Sophie. Have we got any other questions? Maybe just one from, sorry, carry on.
Sorry, Jeremy, great. It's such an explored subject and one that we often get wrong. Really good. Do you have any comments on the sort of terminology that we use? I've come across all sorts of terminology to describe density when they call it specific gravity, but mean density when they call density, but could mean bulk density, and it's all over the show. I don't know if you've also
it's all over the show.
Yeah.
You're right, Matt. It's all over the show, and I made a few comments earlier on. You know, I mean, people tend to call specific gravity something from a pyknometer, but it's not entirely correct. Specific gravity is exactly the same as relative density. Yes. You know, so essentially, when you do Archimedes, you're actually doing to a certain extent. You know, there's a bit of relative density going on there because it's your water should be an SG of 1. So to me, I don't really care. I've kind of got over it. But the most important one for me is what we are trying to get is dry in situ bulk density.
Yes. Yes.
Okay, that is where we're aiming for. And I'm quite happy for people to say SG for pyknometer and density or relative density for the Archimedes or whatever. It doesn't bother me at all. Everybody just make sure that they're if they're in the metals or precious metals, base metal industry, largely we're talking about dry in situ bulk density. Of course, in the coal space, they remove the dry bit, I think. But yeah, but there's lots of nomenclatures all over the place.
Yeah, thank you.
Yeah, Jeremy, just a question from me and maybe just some guidance. Where you maybe have sort of two operations that have sort of become one now, or different areas, and one largely use pyknometer readings and one Archimedes. And you know, we do see some variances between the two methods. What would sort of be the best approach when combining that in an estimate? You know, is it either or? Could you combine the two? What would sort of be the best way to approach that?
Yeah, that's a great question, Nicole, and it's something that I've been asked many times actually, and we've even done some specific studies on this. For me, you should use the Archimedes, right? Because it takes into account alteration, porosity, etc. And what surprises me is there's always this very consistent bias between the two methods. And if it was just the occasional one with a bit of fracturing or something, you wouldn't have such consistency. So I haven't quite worked out the reason for this fairly consistent bias between the two methods. And I've looked at it with different labs, different people doing it all over long time periods, and you're always coming up with this couple of % bias. So in theory, what one should do is take your pyknometer data and correct it. But the question is, does the correction change with time? You know?
Yeah.
And I don't understand it enough to be able to say whether you should be correcting data or not. I think you should just pick one method and run with it. And also try and understand why these differences occur. Was it different in the 1980s to what it is in the 2020s or whatever? But it's just something to be aware that you can, if you run with a pyknometer value, you could be overstating your mineral resource by a couple of %.
Yeah, and that's the difficulty, you know, is and for me specifically is trying to mix the two data sets. It's not going to work too well because we do see this consistent bias between the two. We have done tests, as you say, comparing pyknometer to Archimedes. So, you know, we've kind of resolved with if you're using one method and that's been historically what you used, you stick with that. But, you know, changing something as well in the middle of sort of a campaign or whatever is also not the ideal situation. So it's kind of, as you say, pick something, stick with it, and just justify, you know, the reason for using it. So I think that's probably the best approach.
Yeah, I think so. If you mix it together, there's some interesting impacts if you are running variograms on density and that kind of thing. Because, you know, with density, you're trying to do a variogram of density, you're working with very little variance. There's not much variance to go around to do your variogram with. So if you put another source of variance in, like mixed data types, it could also cause some issues if you have chosen that route. I'm not that big a fan of creating density. I don't think it's that necessary, but you know, you can do it if you want. I'm not bothered either way. But yeah, so it has some variance connotation. So I always like to try and use like with like. If you mix it all together, you're going to get kind of the average of them both, aren't you? So it's probably a lower risk approach.
Yeah.
No,
thanks for that one. There's just a question in the chat. Is LiDAR scanning not used to get the volume?
LiDAR scanning is used to get the surface and the tailings down, but not for the in situ volume that we need to compare the mass with.
Okay, but I don't know if that answered your question. But yeah, if there's any other questions for Jeremy, I think that's that. Great. Thank you very much, Jeremy.
That's a pleasure. Sorry, it's not my usual topic, but I thought it was an interesting one to remind people about.
Definitely.
There's often not an easy answer.